My name is Sarah Payne, and I am a fellow with the NASA-developed national program out of our Athens, Georgia location, which is hosted out of the University of Georgia. I'm very excited to be your MC for the first session today. In this first half, we are going to be celebrating 50 years of Landsat, discussing the amazing work of NASA's Applied Sciences Ecological Forecasting Program, highlighting the NASA-developed and National Park Service partnership, and also showcasing NASA's Wildland Fire program. But before we start with the wonderful speakers that we have lined up for today, just a couple of reminders. The agenda for the session can be found at the NASA Earth Science Application Week event webpage, and the session will last from 1 to 4 p.m. Eastern Time and can be joined using the WebEx link that you used to attend this meeting. And then during our time here today, please stay muted with your cameras off so we can focus on our speakers, and we hope that you'll use the chat function for any comments or questions you may have. And finally, with many people working from home from across the country, there may be a few technical difficulties that pop up, so we appreciate your patience in advance. And now, without further ado, I'll pass it over to Lawrence Friedl for Day 2 opening remarks.
Great, thank you, Sarah. Thank you so much. And welcome everyone. I'll add my welcome to everyone for Day 2. And so really on behalf of the entire NASA team, we're excited that you're here and excited to hear some of the things that we're doing and all the wonderful ways to be using earth science information to inform decision making and really to sort of benefit society. You know, I have to say that nothing in applied sciences makes sense except in light of partnerships. So which is why I'm really excited we're starting off today looking at Landsat, and Landsat 50th is a fantastic partnership with the U.S. Geological Survey and all the history of partners that have been involved with Landsat, as well as a special focus on the National Park Service and the real great, fantastic relationship that the Develop program has, among others in NASA Earth Science, but especially the Develop program and the wonderful world partnership that they have with the National Park Service. I mentioned in my sort of Day 1 comments that, you know, just having great partners that are willing to try new things, to take some risks, to sort of see and iterate if and where earth science information can really help improve their decision making, that it's that partnership relationship that is really, really great. Sometimes it's working with a new partner to sort of explore a space. Sometimes it's working with an existing partnership to go even deeper on what are some new ways to be using earth science information or some different types of earth science information and all. So from that standpoint, first of all, so many, all the partner organizations that have been involved, you've taught us a whole lot in how to do sort of co-production in tracking research and applications and connecting them together. You've also helped us identify what are some new research questions that we might be able to pursue within NASA and the broader earth science community. So let me wrap up there just to say I'm looking forward to a fantastic Day 2. And back to you, Sarah.
Thank you, Lawrence, for those opening remarks. And it is now my pleasure to introduce our first speaker of today, Tim Stryker from the USGS, who is here to celebrate 50 years of Landsat.
Thanks very much, Sarah. And thank you very much, Lawrence, for that great introduction. It looks like I'm having problems with my camera here on my laptop with WebEx, so I apologize for that. But I would like to thank you, Lawrence, and Emily, and just the entire NASA Applied Sciences program for your tremendous leadership and the great partnerships we have with you in so many areas, and also Lauren Childs Gleason and everyone in the Develop program. You always put on such wonderful events. It's a pleasure to be associated with the great work that you do. So I will try to attempt now to share my presentation in some way. And can you hear me okay, first off?
Yeah, your sound is great.
Okay, and then sharing the presentation, I go to more options, or what do you recommend,
Do you
Sarah?
see a share button at the bottom? Is there a share content button?
Close participants, close chat, panel options. I do not see a share content button.
Okay, let me see if I can pull it up from you.
Okay.
for getting the slides up. Thanks for bearing with us.
Okay, no, thank you. Okay, thanks so much, Lauren. So should I just ask for the slides to be advanced when it's time?
That's perfect.
Okay, well, let's move on to slide 2. So I'm glad Lawrence mentioned risks because, partnerships do involve some degree of risk and but great opportunity for reward. And so kind of going back into history with Landsat's 50th anniversary occurring this past July 23rd, 2022, that celebrates 50 years of Landsat being in orbit. And it all started with these two gentlemen, Interior Secretary Udall and USGS Director William Pecora at the time, who if you're a history buff, and I am, I'd encourage you to read up a little bit more on the history of this mission because it's quite an interesting story. And I would say both Secretary Udall and Director Pecora employed some very creative bureaucratic skills to get a civilian land imaging satellite announced, developed, and launched. And after the announcement, the partnership with NASA over the past 50 years has just been tremendous. And not only the history of the launches, the first launch itself, but the program's perseverance through many decades, budgetary fits and starts, a failed commercialization effort, and some really ingenious systems engineering and aerospace engineering going on throughout the whole history. So next slide, please. That is a story for another day, though. I know I have only a brief time frame, and it's great to celebrate our achievements, but we believe it's even more important to plan for the future. And so that's the true focus of our 50th anniversary activities this year in partnership with NASA. If you do want to explore the history more, I certainly would encourage you to attend our Pecora 22 Symposium. There will be a gala event the evening of October 26th in Denver. And more to come on that. But you can see kind of our activities and efforts throughout the year. Right now, I draw your attention to just recently in late July, wonderful events on Capitol Hill with a lunch and learn session for committee staffers in Congress, and a wonderful evening reception also with committee staffers to celebrate the anniversary and talk about past, present, and future plans. Right now, I'm calling in from Sioux Falls, South Dakota, and we will be having the official handover of Landsat 9 from NASA operational control to USGS operational control tomorrow. And so we have some wonderful ceremonies and activities occurring. Our Landsat science team is meeting at the same time. And so we're going to make it a really big year, running through the year with Pecora 22, and even some potential activities into the springtime with the Smithsonian and some of our other external partners. So next slide, please. So these days, there's a lot of excitement about satellites and what they can do, but it is important to remember, and I'm sure many of you already know this, but we often have to explain to our to leadership and our external stakeholders and funders that there are different satellite types for different applications. On the one end, you have the synoptic weather scale observations up to hemispheric coverage for forecasting and nowcasting of weather phenomena. They're optimized at a certain scale and certain spectral bands. On the other end, you have commercial high resolution satellites focus more on monitoring movement of things and people. And to achieve their mission, they're optimized at a very narrow scale, high spatial resolution. And then kind of midway, there is Landsat, which is really optimized for landscape scale monitoring and analysis and understanding land surface change at a local to regional level. And actually completing global land surface coverage every 8 days between two missions. So, and through its history, Landsat has been, fine-tuned, if you will, to landscape scale resolution and spectral coverage, and it becomes an extraordinarily versatile observing system. And a NASA colleague of ours once referred to it as the Swiss Army knife of Earth observations because of its wide range of applications that it can support. So next slide. And regarding commercial industry, it's a very exciting time for commercial satellite systems. We've partnered with NGA and NRO and NASA on access and use of much of the great data that's coming out of these systems these days. But it is important to kind of differentiate once again that commercial satellite systems can play a very important role in augmenting key science observations and global coverage activities. They're not built or designed to replicate Landsat's capabilities for providing the long-term, well-calibrated, full-spectrum science quality data due to their size, weight, and power considerations. And furthermore, they're not, by and large, they're not global land survey missions. They tend to to point and shoot where their customers are most interested. And they're not carrying the more expensive visible shortwave infrared and thermal infrared instruments and all the kind of associated components to provide, very high quality, highly stable observations in these spectral bands. So again, Landsat, very complex science instrument in space, much like other NASA built and operated observatories. And that's really kind of the important takeaway in terms of, the ability for it to be used over long periods of time, anywhere on the land surface for key science and research and operational activities. Next slide, please. So this is the kind of applications wheel that we like to show in terms of, that kind of Swiss Army knife aspect of Landsat's use. And you can see, many organizations internal to the government and external using and benefiting from Landsat in these wide variety of applications. I would add that an Earth observations assessment, according by the U.S. Group on Earth Observations, which Lawrence is one of the leaders of, in 2016, ranked Landsat as the second highest in societal benefit impact out of more than 1,000 Earth observing systems and surveys, coming in second only behind GPS in terms of the benefits across a wide range of applications area and being the single most used land imaging data set by federal users. And so that's an important data point for us and useful in terms of our education and outreach. And you can see the wide range of applications here, which I'll attempt to cover very briefly. I would point out also a very important component that's not listed here as a primary application, but it's heavy use in Landsat's heavy use in remote sensing education and training work. Next slide, please. The National Research Council in 2013 said that the economic and scientific benefits to the U.S. of Landsat imagery far exceed the investment in the system, and that's a recent validation of much of the data we and others have collected on the economic value, and the latest one being an economic study done by our Fort Collins Science Center, which found that Landsat returns approximately $3.45 billion in economic benefit each year, and then that's rising over time. You see the earlier study that took place in 2011. So again, we're very pleased with kind of these findings and understanding how impactful and useful Landsat can be. So now I'd like to turn to a quick run through of Landsat applications, and if you could advance to the next slide, please. As I mentioned before, really the wide range of applications is something that we think makes Landsat unique, and it's useful for climate research, as you can see here, through the rise in surface temperatures measured by Landsat since its inception, being correlated with other data and information, resulting in a finding by U.S. Global Change Research Program that Landsat is a critical observatory for climate change research. And that's just kind of the start of it, because climate is the sum of many parts in terms of water resources, quantity, quality, agriculture yield, wildfire risk and impact, invasive species detection and analysis, glaciology, forestry, ecosystems health, urbanization, and other land use and land cover change analyses. And so, due to these reasons and the very high usage of Landsat in education and training, I like the Swiss Army knife analogy, but I also like to call Landsat the people's satellite in terms of the wide range of applications and use. Hundreds of thousands of users in the United States alone. Next slide, please. This is just an illustration of two types of Landsat applications on water usage and water quality. To the left, examples of evapotranspiration monitoring to support effective water rights management and transfers in the Western U.S. And to the right, you'll see a very colorful image, but very meaningful image of Western Lake Erie and harmful algal blooms occurring due to phosphate runoff from Ontario, Michigan, and Ohio. Next slide, please. The global nature of Landsat enables us to classify and better understand a real wide variety of coastlines around the world. Rocky shores, sandy beaches, mudflats, granite mountains, chalky bluffs, and even basaltic columns, which I believe you can see there on the slide, help us better understand kind of the nature of the coastlines around the world and environmental impacts occurring to them due to global change. So you can see all coastlines other than Antarctica, and this is a joint project through the International Group on Earth Observations, the Geoecosystems project associated with the Marine Biodiversity Observation Network. Next slide, please. So Landsat's not only versatile, but you can say that it plays well with others in terms of pairing here, for example, with Europe's Copernicus Sentinel-2 land imaging mission to increase temporal coverage of environmental phenomena such as invasive species mapping, and particularly important in the Western United States, mapping invasive grasses such as cheatgrass. You can see examples here of the mapping over time and support to efforts to control these species and the fire impacts. Next slide, please. Land Fire is a vegetation, fire, and fuel characteristic mapping program managed by the U.S. Department of Agriculture and the Interior Department. And these Landsat-based products facilitate national and regional strategic planning, reporting of wildfire, and natural resource management activities, and results of tactical incident response to large wildland fires. Ultimately, this information works its way into policy support, such as the Wildland Fire Leadership Council and other federal agency activities. Next slide, please. And Landsat has shown us the two sides of development in the Amazon forest and the different types of deforestation patterns that can take place. Some of you may be familiar with these types of global products that are being used by governments to better manage forests and ecosystems. You can see this one example, kind of a fishbone pattern of deforestation in the Amazon rainforest. And so this type of infrastructure development opens markets and allows local people to commercialize goods and services and improve the local economy. But at the same time, the destruction of the rainforest creates a lot of long-term trouble, both environmentally, locally in the region, but also in terms of greenhouse gas emissions and climate change. And so we work with national authorities, with NASA, USAID, State Department, on improving capacity building for monitoring and management of these tropical forests worldwide. Next slide, please. And if you click one more time, you'll see just a quick depiction of the Google Earth time-lapse product, which draws heavily upon the Landsat archive to rapidly visualize changes to the Earth's surface over recent decades, which they're using now as an educational tool for publicizing, these types of land surface changes and enabling, new types of science, long-term longitudinal research and education efforts. Next slide, please. Landsat also helps to monitor and map changes in coastal wetlands. And you can see the example here of the changing nature of mangroves and salt marshes in response to climate change throughout Florida, in response to warming temperatures and rising seas. And again, the long-term archive unlocks a lot of new insights into how these habitats have changed and allows local and federal authorities to better understand and try to respond to these impacts. And I'd note this work has been done by Cheryl Dowdy. She's a NASA postdoctoral program fellow, and she's a member of the Ladies of Landsat group, which is the topic of my next slide. You could go to that, please. So the Ladies of Landsat are doing all kinds of cool things with Landsat, we're very interested in their, community interest and support and education outreach. They're a great group that's committed to diversity, equity, and inclusion of women and other underrepresented groups in remote science. And they see Landsat as a readily available, easily usable, and highly cited data source, both for career advancement and then for societal benefit that so many of these ladies are working on. And so pictured here, you can see the group multiple times with our Assistant Secretary for Water and Science at Interior, Tanya Trujillo. And they were all on hand to showcase the regional U.S. applications of Landsat in the 50th anniversary reception we had on Capitol Hill last month. And if you look around, you'll see the various posters that each of them had provided. Next slide, please. So as I noted, we're seeking our 50th anniversary year, not just as an occasion to look to the past, but be concerned with the present and looking forward. And so we've devoted a lot of time and effort recently to research and educational engagement activities on the value of Landsat in particular and remote sensing in general. You can see the full series of state fact sheets that was released just prior to the congressional reception. We partner also with Jake Richmond and Ginger Butcher and then the wonderful team, comms team at NASA and at Goddard on producing publications. You see a very nice one down below on different applications of Landsat over the past 50 years. Next slide, please. So when Landsat data was made freely and openly available in 2008, user downloads grew exponentially from about 2,000 images sold in 2008 to more than 30 million image downloads annually in the past few years. And these continued IT advances enable users to analyze, download and analyze long time series over large regions and even globally. Creating an entirely new realm of land cover, land use change science, and contributing greatly to our understanding of climate change. In addition to that, we're trying to stay in tune with the latest technologies and ways to access data. So last year, we completed a massive job of reprocessing the entire Landsat data record, applying revised algorithms to improve the data's radiometry and geometry, calling it Collection 2. And to do that, we leverage the Interior Department's Amazon Web Services contract, which enabled amazingly fast processing and the prompt hosting of that data. And since that data has been out in the cloud, we've seen, again, rapidly growing, large numbers of user accesses. They're called data takes. And we're very excited about this capability and learning more how users are actually interacting with and doing science in the cloud. We see how the data has been made available as cloud optimized geotiffs and searchable by spatiotemporal asset catalog metadata. And much of this is interagency work. It's work with ESIP and other nonprofit organizations, all in the service of making data more readily available and applicable for users. So next slide, please. I'll just show you here, there are many ways to access data from our Earth Resources Observation and Science Center here in Sioux Falls, South Dakota. Mention, that these, oh, thank you. Next slide, in terms of a little more history, shows you how we've managed to attain this 50-year continuity and assemble the world's largest and most globally comprehensive land imagery archive. And you can see, the different color bars there. We've had some ups and downs in our history with spacecraft operations, one launch failure in Landsat 6. But again, remarkable project management and engineering support and operations. So we're now in pretty good shape for the time being. Next slide, please. So given the ups and downs we've had in policy, we've worked very hard in recent administrations through multiple national space and Earth observing policies and plans to really establish a robust governance approach to sustaining and improving land imaging into the future. And you can see how we're structured here with NASA in terms of interior and NASA leadership for oversight and direction and resourcing and investment of future land imaging missions. Next slide, please. I would say that the Landsat program, per se, between NASA and NOAA exists in kind of a complex operating environment, if you will, in terms of, two different agencies involved in development of space systems and ground systems, launch, checkout, handover, and operations. Both agencies heavily engaged in research and applications. And this is all at the same time that, we share or we have different oversight committees, doing congressional oversight. So there are key issues in terms of aligning budget requests, program priorities, and spending. And that's why we have this sustainable land imaging governance approach that we've adopted as a very good model to ensure stability and continuity in the future. Next slide, please. So Landsat 9 is actually the first mission under the Sustainable Land Imaging Program created by NASA and USGS, and picture perfect launch on September 27th, 2021. Thanks to NASA, extremely accurate launch injection, lots of leftover fuel, and the operations have proceeded largely on schedule with excellent performance by the satellite and the ground systems. The data has been delivered for many months now, and NASA will be turning over the mission to us, as I said, tomorrow. Next slide, please. If you could click on the box there to see if the audio runs under the Vice President. I guess not. That wasn't enabled, but I can just summarize quickly. It was very nice to have a sitting Vice President mention your mission and your program and show the excitement about the benefits of it and the success of the recent launch. You can see here Goddard Director Andrushik discussing Landsat 9 images with Vice President Harris during a tour that they had out at Goddard Space Flight Center. Our USGS Director, Dave Applegate, is down in the lower left-hand corner inspecting the OSAM-1 demonstration mission for Landsat 7 servicing in the future. Next slide, please. So we're in a pretty good spot now, but knowing Landsat's complicated history, we can't rest on our laurels. We've got the most capable constellation we've ever had with Landsats 8 and 9. But in looking toward the future, we're aware of the need to replace Landsat 8 as soon as possible. And thus our drive to seek funding and approval of the Landsat Next system design, which was developed by a joint NASA-USGS architecture study team over a 2-year period. And right now, some key final decisions are on the table among NASA, Interior, USGS, and OMB leadership. Next slide, please. I would just briefly show the status of Landsat 8. As I said, it's operating great at this time, but it does have some underlying concerns moving into the future. It's already 9 years old. It had a 5-year design life, and a number of kind of lower level subsystem issues are points of concern, and so that's why we're eager to get Landsat Next on contract and developed and launched. Next slide, please. So this is where we are now, looking to move from Landsat 8 and Landsat 9 into a Landsat 9 and Landsat Next architecture, also including collaboration with our European partners on Sentinel-2. The design that has been developed by the architecture study team and approved by our joint steering group was within the traditional cost envelope for Landsat missions, even costing less over its full life cycle than previous Landsat missions. And it's demonstrated technology with a lot of good work done by NASA's Earth Science Technology Office and other folks at Goddard and USGS. I would add that no one mission can cover all land imaging needs, and so that particular the Landsat Next concept and the next phase of our sustainable land imaging program involves substantial commercial data buys and international partnerships to augment the core Landsat Next imaging capability. So you can see here what announcements had gone out from NASA previously in terms of sharing the documented user needs that USGS has invested much time and effort into providing through a very structured elicitation process, which resulted in the type of user needs that could be addressed most efficiently through Landsat Next capabilities. You can see to the right. So you can see highlights of improved revisit frequency, higher spatial resolution, additional spectral bands, and continued radiometric quality and traceability back through the entire earlier Landsat data record. Next slide, please. I would mention also in terms of the user needs process, it's much larger than just a USGS and NASA science needs activity, but involves all federal agencies and many of their external stakeholders in terms of the products and services they provide, even to the state, local, nonprofit activities nationwide and globally. And so we're seeking to convene all these communities in Denver in October 23rd to 28th. We certainly hope you'll join us there. There's a lot of planning going on for it. We've invited our secretary in Holland and NASA Administrator Nelson, understanding their calendars don't usually fall into place until a few weeks before the actual event. But we certainly would love to have your entire community. Some of you doing wonderful applications in science. Some of you may already be signed up to present. But if you've not, you can come, listen, learn, and exchange your views with all of us, and we can kind of look forward to the future together. So the final slide, just like to thank you today for the opportunity to speak with you about our past, present, and future, and wanted to end with a very nice, colorful scene of the Betsiboka River in northern Madagascar, where you can see extensive logging leaving the land vulnerable, and rich iron-rich soils being washed into the river, leaving these sediments and colors into the estuary delta. So with that, I'll pass it back to my NASA colleagues, and thank you very much for your attention.
Yeah, thank you so much, Tim, for sharing with us the background of Landsat, its many applications, and also its enduring value. And just a quick extra thank you to Tim for taking the time to speak with us all during such a busy time with the Landsat meeting and transition. And I will now pass it over to Dr. Keith Gaddis to give an introduction to the Ecological Forecasting Program.
Hello, my name is Keith Gaddis, and I am the Program Manager for the Ecological Forecasting Program at NASA headquarters. Today, you're going to hear about some of the projects and activities supported by our program and the impact that they have for life across our planet. And when I say life across our planet, I mean it. We often use the line saving life on Earth as the overarching objective of our program element. Our program is aimed at preserving the vast majority of life on Earth in all shapes and forms, on land, in the water, and in the air around us. We are focused on protecting the essential diversity of Earth's life. We do this not just because we have moral obligation, but because the loss of our planet's biological diversity has a tangible consequence on the lives and livelihoods of our species, humans. People are dependent on nature for the air that we breathe, the food that we eat, and the water that we drink. The Ecological Forecasting Program enables the use of Earth observations to make strategic and informed choices about how we allocate resources and efforts to preserve life on Earth and the benefits it provides to us. Here you see a snapshot of the projects we currently support based on the project end user, geographic extent, theme of the decision-making need, and primary targeted biome. All of our activities are directed toward addressing a need that has been explicitly stated by an end user. These end users are members of the project team and ensure the ultimate product will address their need and can be sustainably transferred to their organization. To guarantee this, end users contribute a cost share to each award. These end users share some need that is commonly oriented towards ecological conservation. We most often work with government partners at the state, national, or international scale. We also frequently work with the private sector, conservation agencies, and even commercial companies who have a stake in ecological preservation. Our projects span the globe, from preserving threatened tiger habitat in Southeast Asia, establishing new marine protected areas in the Southern Ocean where pockets in sea ice are essential for biodiversity survival, to guiding land management in South American tropical forests to ensure the preservation of the greatest number of species per dollar of government resource spent. These examples highlight the wide breadth of conservation topics our program supports. Through these activities, our work directly advances the ability of NASA Earth observations to inform conservation decision-making. Currently, more of our projects are on land than in the water, although historically this division has been fairly even. In fact, one of my favorite past program-supported projects is set within the Delaware Bay. Sturgeon are an endangered species and are thus federally protected. When caught in nets by fishermen, they cause a significant nuisance and potential liability. These massive fish can weigh upwards of 800 pounds, capable of significantly damaging nets or even injuring fishers trying to untangle them from the nets. Using remotely sent sea surface temperature and ocean color data alongside acoustic tracking records for the sturgeon, Matt Oliver at the University of Delaware and his team were able to not just map current sturgeon hotspots, but additionally forecast where sturgeon are likely to occur in coming days. This application, the Atlantic Sturgeon Forecast Warning System, delivers alerts through a web application, online flyers, and text updates to a mobile device to update end users of the risk of encountering sturgeon in the Delaware River or Bay. The tool also issues a risk forecast for encountering the Atlantic sturgeon 3 days out. Today, you're going to hear about other successful projects from our program and how other areas of the Applied Sciences program is working in this space.
Great. Thank you to Dr. Keith Gaddis for that great overview of the Ecological Forecasting Program and its impactful work. Next, we have Kelsey Herndon speaking on the SERVIR Amazonia Mangrove Service.
Great. Thanks so much, Sarah. I'm really excited to share with you guys today about the Severe Amazonia Guyana Mangrove Monitoring Service. SERVIR is a joint program between NASA and the United States Agency for International Development, and we work with leading geospatial organizations around the world to build capacity and using Earth observations to address all sorts of different environmental challenges. SERVIR has 5 regional hubs, and the work that I'm going to be talking with you about today is coming out of our Amazonia hub, which is headquartered at CIOT in Cali, Colombia. Next slide. Thanks. So Guyana's mangroves are an important coastal ecosystem. They support ocean defense, carbon sequestration, livelihoods, biodiversity, but they are under threat primarily from agricultural expansion, but also increased urban development and natural erosion. Guyana's National Agricultural Research and Extension Institute, or NARI, has the mandate to monitor and restore this important ecosystem. The challenge is that this team is extremely small, and prior to this service, they relied almost exclusively on kind of boots on the ground monitoring. So the idea was that we could incorporate remote sensing to support the really great work that NARI was already doing. Next slide, please. So the objectives of this service was first to develop a tool that would continuously monitor the extent and health of Guyana's coastal mangroves on at least an annual basis. We also wanted to provide a transparent source of information on the status of Guyana's mangroves that would be accessible by any government organization, but also local NGOs and other stakeholders. And we also wanted to support NARI as the expert source on all things pertaining to Guyana's mangroves by building their expertise in cloud computing and remote sensing. Next slide. So we kicked off the service development with a series of NASA-led trainings on using SAR and optical data, including Landsat, to monitor mangroves. And then NARI has led the co-development of a Google Earth Engine-based tool with support from SERVIR Amazonia and NASA. And the tool consists of a GE-based machine learning classification of mangroves, and we're working now to incorporate additional characteristics, which I'll talk about in a minute. And finally, in development, we have a web-based GUI that will be easily accessible by everyone. Next slide. So preliminary results of the mangrove classification indicated more than 3,000 hectares of mangroves were lost between 2015 and 2020. And so as part of our field validation, we identified several areas of interest, and NARI conducted field validation exercises using some of their drones. So on the left here, you can see we've highlighted an area, a vast area of mangrove deforestation that was confirmed in field to be caused by coconut farming. Next slide. NARI initiated a mangrove restoration program in 2010, and they've applied various types of interventions at 22 sites between 2010 and 2020. So another way that we're going to be using this service is to monitor these restoration sites. So in our pilot region, we found significant increase in mangrove extent, 177 hectares, across 75% of the restoration sites that we evaluated. And so we're looking forward to kind of expanding this use of the service. Next slide. So we've just wrapped up year 1 of service development, and we're starting year 2, and we have a lot of exciting plans. We're going to be working with the SCAP to model biomass and carbon stocks to contribute to REDD+ reporting. We're going to be evaluating changes in forest fragmentation and trying to better understand the impact of these natural erosion and mudflat dynamics. And we also plan to release a public data dashboard that will summarize these changes in mangroves and be available to the public. And, you know, Lawrence, at his opening remarks, he mentioned the importance of partnerships. And I really want to stress that NARI has been an absolute champion for SERVIR and for the co-development process. And we're really proud of the work that they've been able to accomplish so far and excited about everything that they have planned in the future. Next slide. So with that, I'm happy to take any questions in the chat, and also feel free to reach out via my email, which is listed here. Thanks so much.
Great. Thank you so much, Kelsey, for diving deep into Guyana's mangroves and how SERVIR Amazonia has worked with the community to provide information and build expertise. Upcoming, we're going to hear from Hannah Rigdon with a feasibility study snapshot of Illinois' ecological forecasting project.
Hi, everybody. Thank you for joining. I'm Hannah, and I've been working along with my teammates, Vanessa Machuca, Dana Myers, and Christiana Saldana with the NASA Develop program, and we have spent the past 10 weeks mapping inundation in the lower Illinois River Valley. For this project, we partnered with the Great Rivers Land Trust and a couple other local organizations to map inundation extent and duration, which will help our partners in their identification of priority areas for wetland restoration. Our project aimed to determine the feasibility of mapping inundation extent and duration using synthetic aperture radar from the Sentinel-1 sensor, and we also compared our results with a water classification derived from Landsat 8. Next slide, please. So because this is a feasibility study, the snapshot is going to focus mostly on our methodology. Like I said, we used synthetic aperture radar from Sentinel-1, and we looked at two different time periods, 2019, which was a flood year in Illinois, and 2020, which was a drought year. Our goal was to classify the SAR imagery into 3 different classes: open water, inundated vegetation, and then kind of everything else. And we did this using a thresholding methodology. So to do that, we first looked at local river gauge data from the U.S. Geological Survey and identified periods of high flood, which we knew would have inundated vegetation imaged in those images. Then we mapped the full range of pixel values into histograms to try to get an idea of the full range of pixel values that we were trying to classify. Then from our histograms, we could begin to pull out different thresholds or pixel ranges for each of our land cover groups, mostly being open water and inundated vegetation. Then we manually applied these thresholds to all of our images, and that's how we classified the synthetic aperture radar images. Once we were kind of satisfied with our results, we compared those to the dynamic surface water extent product that is derived from Landsat 8, and we found that just within our open water classification, we had an 86% agreement with the D-Sweep product, which we were pretty satisfied by. Next slide, please. So once we had our individual SAR images classified, we could begin to count how many times a pixel was inundated over the course of our study period, which would tell us more about inundation duration. And we counted inundation as being classified as either open water or the inundated vegetation class. And in our maps that we're going to show you on the next slide, pixels that were more frequently inundated are shown as a darker blue, and pixels that stayed dry for most of the study period are white colored. And these maps will help to display patterns of inundation over time that our partners can use to identify places that are consistently inundated or seasonally inundated or never inundated, which can be indicative of wetland conditions on the ground. Next slide, please. So we're going to focus on this smaller portion of our study area for this presentation. And you can see in this time lapse on the right, this is from 2019, which was our flood period, and we can see that the water levels were rising significantly throughout the study period. The dark blue right in the middle showed a failed levee, meaning that the water level rose so high that it kind of spilled over this protective barrier into the agricultural land it was supposed to be protecting. And we can see that, like when a levee fails, the water does sit in the agricultural field for a long time. And we were able to discuss this finding with our project partners, and they validated for us that the levee had indeed failed, which kind of gave us some confidence that our classification was matching results of what our partners knew to be true during this flood period. And then this image on the left is our map for inundation extent. The darkest blue shows pixels that were always classified as wet in both the flood year and the drought year. The brown is land that was classified as always dry in both years, and then that light turquoise color shows land that was wet in 2019, the flood year, but not in 2020, which was the drought year again. We can see that our extent map also picked up higher than normal water levels in 2019 as the inundation extent is larger for 2019. To wrap up, we were really excited about our results, and as were our partners, and we're really glad to be able to provide valuable insight for our partners on inundation patterns in the lower Illinois River Valley. We were able to generate both the inundation and extent maps from the SAR imagery, and our partners will go on to use these to try to identify wetlands in the lower Illinois River Valley and use them to inform their purchasing and conservation practices for the foreseeable future, which is really exciting. And that is all I have. Thank you.
Wonderful. Thank you, Hannah, for going into detail on such a fascinating project on inundation and extent in Illinois. Really wonderful graphics you and your team produced there. And thank you all to all of our speakers for that wonderful overview of ecological forecasting applications. And now covering a wide array of application areas, including ecological forecasting, I'm extremely excited for our upcoming speakers, highlighting the NASA Develop and National Park Service collaboration. We've been building this partnership for over the years with more than 70 projects addressing a number of topics seen here, such as water quality monitoring, air quality monitoring, and modeling light pollution. This summer, Develop has conducted 4 projects partnered with the National Park Service, which we will dive into here shortly. But before we do, I want to introduce you all to Randy Stanley with the National Park Service Colorado office as the NR Funding and Reporting Coordinator to speak more on this long-running partnership.
Thanks, Sarah, and thank you, everyone. It's a real privilege to be here. And this partnership with NASA Develop is very, very important to us for a number of reasons. Of the 70 projects that were mentioned, roughly half of those are in my region, with approximately 5 active this summer. This translates to roughly $900,000 of NASA staff support that is really critical for us. In addition to the projects that were mentioned, just one specific example at Chaco Culture National Historical Park, one of our projects with NASA helped identify ancient Chacoan roads and communities that extended outside the park, some of which are currently threatened by development and minerals exploration. As a land management agency, the National Park Service, spends a great deal on park operations, and in my role as a natural resource funding manager, I can tell you that 8% of our budget goes to natural resource support, and so some might argue that we're chronically underfunded, and as a result, this partnership is very, very important to us, and we're very grateful. And just to highlight some of the project outcomes and where we want to go moving forward, our previous NASA Develop coordinator for the National Park Service, Don Weeks, had met with Dr. Kent Ross, and we've agreed on the following recommendations moving forward as phase 1. We look forward to reconnection and rekindling of this partnership to solicit for new NASA Develop project concepts. And in addition to the 5 projects that we have going in 2022, we'd like to incorporate NASA's excellent communications and outreach program to expand the project deliverables and reach a wider audience if possible, including park visitors. We've had several meetings between NPS and NASA communications outreach staff exploring some of those options and soliciting parks for what specific deliverables they would prefer. And finally, in 2023, we are hoping to enhance the work experience for NASA Develop project teams and those incorporated student interns with select invitations to visit parks that they are working with on these important projects. And again, thank you. This is very important, and I'm very privileged to be here and highlight this partnership. Thank you.
Thank you, Randy, for those kind remarks. It's really wonderful to hear your experience and perspectives, and we are really excited to continue this partnership into 2023. We will now hop into those 4 partnership projects with the National Park Service that we've had conducted this summer. To start, we have a project that's very near and dear to my heart as it is located out of our Georgia location. So without further ado, here is Vanessa Bailey, who will be presenting on Yellowstone ecological forecasting.
Thank you, Sarah, for that introduction. Hi, I'm Vanessa Bailey, and I'm a member of the Yellowstone Ecological Forecasting Team. We have been assessing change in aspen extent in northern Yellowstone National Park this developed term. We have really enjoyed working with our partners, Yellowstone National Park, Utah State University, and the University of Wisconsin-Stevens Point. Next slide. Aspen and Yellowstone have been affected by the removal and reintroduction of wolves in the park. Wolves were extirpated from the park in the 1900s, which led to an increase in elk population and greater browsing on aspen. Wolves were reintroduced in the 1990s, which caused the elk population to decrease and the potential for aspen regeneration. Aspen only covers about 1% of the total land area in Yellowstone, but it is estimated that over 95% of aspen stands in the park are over 80 years old. Old stands are more vulnerable to decline. Aspen provides a vital food source, habitat, and shelter for a variety of wildlife, and therefore is a keystone species. Aspen supports increased biodiversity. Given its importance in providing habitat and increasing biodiversity in the region, understanding its extent is critical. Without aspen, key ecosystem services may be lost, which is why there is concern over its decline. The main objective of our project was to determine aspen extent over the last few decades to understand the role of trophic cascades and inform rewilding decisions. Next slide. We use two different methods to try to identify aspen extent. First, I will talk about the random forest approach. Random forest is a classification method using decision trees to form groups from predictor variables and training data. We used several predictors like true color, shortwave infrared, and near infrared bands, and created others like NDVI or normalized difference vegetation index and tasseled cap indices to feed into the model. We also used partner-provided points of a variety of land cover classes to run the classification. After running the model, we checked for accuracy by comparing modeled aspen extent with known aspen locations. The other approach we used required an assessment of phenology. We plotted NDVI for aspen and conifer sites over the year to identify periods of peak greenness and senescence, or change in leaf color. Deciduous species show a greater change in NDVI over the year because of the leaf color change, while evergreen species have relatively constant NDVI values. These differences make it possible to classify areas that could be aspen and other deciduous species. We subtracted the summer and fall NDVI images, which allowed us to determine change in NDVI for those two key time periods and set a threshold to determine deciduous areas. We again compared to known aspen locations. Next slide. Overall, we found that aspen expanded in some areas and contracted in others over the study period. The random forest and phenological approaches showed marked differences, but tend to show a decline from the 1980s to present day. This trend could, however, be attributable to changes in resolution of our data, that is, overestimations in the past. This map shows a comparison of the two methods for the year 2011, but we also performed analysis to see how aspen extent has changed since the mid-1980s through 2019. The random forest approach is represented by purple, phenology by green, and the overlap by black. Known aspen locations are shown in the inset map by yellow points. As you can see, there is a fair amount of agreement between these approaches in that inset, but also a lot of variability across the greater study area. These results help improve understanding of trophic cascades and the impact of rewilding decisions, and we hope they can inform Yellowstone National Park with future decision-making. Yellowstone National Park has been instrumental in this work, and it's been a pleasure working with them. Thank you.
Really wonderful work there, Vanessa, and thanks for going into detail on that partnership. We will now go to Sam Majumder to talk on another feasibility study snapshot with the National Park Service. He will be speaking on Grand Valley ecological forecasting too.
Thank you, Sarah. Good morning, everyone. Thank you so much for attending this talk. My name is Sam, and I'm a part of the Grand Valley ecological forecasting team with the NASA Develop, and we are based out of the Pocatello, Idaho node. This talk will be about forecasting land cover change in the Grand Valley region in relation to the pinyon, juniper, and sagebrush habitats, which are endemic to this region. Right at the onset, I would like to thank our science advisor, Keith Weber and Joe Spruce, for their support and feedback, which helped us immensely over the course of this project. I would also like to thank our fellow Brandon Elizabeth Wilcox for the guidance and support throughout the project. Next slide, please. I would also like to acknowledge the support from our partners at the National Park Services and at the Bureau of Land Management, without which this work would not have been possible. The Grand Valley region overlays the border between Mesa County in western Colorado and Grand County, Utah. For the benefit of our project partners, we were mostly interested in the ecosystem within the Colorado National Monument, McInnes Canyon National Conservation Area, and Dominguez Escalante National Conservation Area. The spring 2022 term conducted a historical study of exploring the data from 1985 to 2020, and the summer term has focused on the forecasting the change for years 2025, 2030, and 2040. Our objectives in this project were forecast future land cover change within our study area and to field validate areas of vegetation decline. This was in relation to places within the study area where vegetation decline was hypothesized to be caused by beetle infestation. Next slide, please. To identify the important drivers of land cover change and to elucidate their relative influence, we modeled the variation of yearly normalized difference vegetation index, or NDVI, within our study area as a function of elevation, annual average maximum minimum temperature, and yearly cumulative precipitation. We used a machine learning approach in relation to our modeling. The dataset was divided into a training and a test set. Data from 1987 to 2013 was used as the training data, and data from 2014 to 2020 was used as the test data. A random forest algorithm was trained on the training dataset by using target-oriented cross-validation. R-squared was used to evaluate the variation in NDVI explained by the predictor variables, and the mean decrease of root mean square error was used to compute the relative influence/importance of each variable. Then the trained model was applied to the test dataset to evaluate the predictive capabilities of the model/predictors. In this way, we evaluated whether our model was overfitting the data or not. Elevation and aspect were the two most important drivers of NDVI variation, and these were used as input variables when creating forecasted land cover change maps via the Idrisi-Terset land change modeler. Terset land change modeler was also used to perform land change analysis. Next slide, please. Our analysis showed that shrubs had the greatest losses in the Colorado National Monument and the McInnes Canyons National Conservation Area, whereas trees had the greatest gains. Our forecasting analysis also show a substantial conversion of shrubs to trees within the Colorado National Monument by the year 2040. In regards to our field validation of potential beetle-infested areas, we created a georeferenced shapefile of the points of interest and a survey 123 to send to our partners so that they could collect data from the field. The survey asked the partners to assess the primary cause of disturbance and the health of ecosystem, and to verify whether the selected points were the site of tree mortality attributed to bark beetle infestation. These ground validation points were selected in areas of consecutive vegetation decline of 3 or more years. Our partners at the National Park Services also selected points of no consecutive vegetation decline to collect as reference points of healthy vegetation. For additional validation, satellite imagery was used to identify areas of green and healthy vegetation, as well as brown-colored beetle-infested trees. One interesting result from the analysis was that the ground points matched the satellite estimated areas of the beetle infestation approximately 69% of the time. One interesting result from this analysis was that ground validations were performed by our partners at the National Park Service and a team of citizen science volunteers on a 10-meter predetermined plot. Finally, for future work, we would like to incorporate more pertinent climate variables in our analysis and to take into account as well as assess how disturbances like fire and beetle infestation affect land cover change. Thank you so much once again for attending this talk.
Thank you, Sam. Great to hear how by working closely with your partners, you're able to get direct field validation for this project and provide really robust end products. Up next, we have Gillian McNamara speaking on a project impacting some of my favorite national parks. Here is the Delaware Basin Ecological Forecasting Project.
All right, thank you, Sarah. Hello, everyone. My name is Gillian, and I'm going to be presenting for the Delaware Basin Ecological Forecasting team with our project that focuses on identifying vegetation trends and atmospheric stressors in the Guadalupe Mountains and Carlsbad Caverns National Parks. Next slide, please. So our project focuses on two national parks located in New Mexico and Texas, Guadalupe Mountains National Park, we have abbreviated as GUMO, and Carlsbad Caverns National Park, abbreviated as CAVE. Both these national parks fall adjacent to the Delaware Basin, which is the namesake of our project. And in the surrounding area, there has been an increase in fracking since 2012 when it began in the area. And this raised concerns with the National Park Service as they didn't want any of the potential nitrogen dioxide pollution that could have resulted from this fracking activity to impact any of the parks. So from this, a developed project was created to map any potential nitrogen dioxide pollution that could have resulted from this. And the previous developed project, the Delaware Basin Health and Air Quality Team, found that nitrogen dioxide pollution has been increasing from 2010 to 2021 near both of the parks. But of course, the project partners were still very concerned about the effects that could have on vegetation, as well as how that could in turn affect park tourism, which is where our team comes in. So we aim to quantify any changes in vegetation health, as well as the effects of the larger mega drought affecting the larger American Southwest in order to account for any vegetation changes that could have resulted from nitrogen dioxide pollution. Next slide, please. To do this, we use data from 3 different Landsat sensors, as well as the GPM iMerge dataset. We use GPM iMerge to model precipitation across our entire study period by downloading monthly data from Earth data on the first of every month, and then creating line graphs for precipitation time series for each one of our study areas. Landsat data we obtain from USGS Earth Explorer and done seasonally with a single date from each season, which is each represented by seasonal ranges. For example, we used a single date from December to February to represent a winter date, etc. And from there, we derived 2 indices to represent vegetation health changes and vegetation moisture changes. We use normalized difference vegetation index, which abbreviated as NDVI, and normalized difference moisture index, abbreviated as NDMI. Once we derived these indices for each of our study areas, we calculated percent change in each of these indices starting at a baseline of 2010 to create our change detection maps, which we compiled into GIFs, which you'll see on the next slide. Next slide, please. Oh. All right, there we go. So bring this together into results. Using GUMO here as an example, as Guadalupe Mountains, we noticed there were similar trends in NDVI, NDMI, and precipitation across both of our study areas. We found that NDVI values, which represents vegetation health, was decreasing from 2010 to 2014, but then showed a much more substantial increase for the range of our study period up to 2021. NDMI values decreased, however, for the entirety of our study period, which correlated well with the decrease in precipitation that we also saw, which just validates the impacts of the drought that are having on vegetation. So from here, we compared the results in NDVI and NDMI to the previous plume data of nitrogen dioxide from the previous term, and we were not able to find strong correlations between the intensity and location of the nitrogen dioxide plumes and any vegetation declines. So we concluded that the effects of nitrogen dioxide plumes on vegetation are inconclusive from our data. We did, however, find some trends in elevation and vegetation type across both of the parks that were very similar to one another. Specifically, we saw that vegetation health in the higher elevations was increasing, while vegetation health in the lower elevations was decreasing. It is also important to note that in the higher elevations, vegetation is primarily pinyon juniper, such as like woodlands, and vegetation in the lower elevations is primarily shrublands. So we saw these significant trends in vegetation as well as elevation, which could be investigated further in other projects, as we were not able to look into this in extreme depth and see what the potential causes of these trends could be. So from these results, our partners with the National Park Service could very much better understand these trends in vegetation that are happening right in both of these parks, and make management decisions that impact the ecological health of these parks and protect the parks for future generations to come. So that's all I have for everyone. Thank you.
Thank you, Gillian. And what a fascinating combination of different application areas with pieces of both health and air quality and ecological forecasting in this project and partnership. We will now hear from the team with the Western Sonoran Desert Water Resources, specifically Seamus, Geraty, and Susan Washko. Take it away.
Thank you. Next slide, please. The Sonoran Desert stretches from western Arizona down into Sonora, Mexico. And there aren't a whole lot of water resources in the desert, but tucked away throughout the mountain ranges are pools called tinajas, or rock pools. These are eroded depressions and rock outcrops that fill with rain and then slowly evaporate over time. And that amount of time between filling and drying is called the hydroperiod. The hydroperiod is really important for structuring aquatic biodiversity, and it's really important as a measure of when resources are available for wildlife on the landscape that depend on these water sources for drinking water. With climate change, we're expecting the hydroperiods to be affected because with increased temperatures, we expect to see increased evaporation rates. And if rainfall decreases, we expect to see less filling of these pools to begin with, which could really hinder aquatic biodiversity and wildlife resources. So we were really excited to reach out through the Develop Partnership to better understand how climatic factors are affecting these hydroperiods and get a better understanding of risk to water permanence in these tinajas. Next slide.
Thanks, Susan, for the introduction to the project. My name is Seamus Geraty, and I'm a member of the Western Sonoran Desert Water Resources team with NASA Develop. And I am going to speak a bit to our project methodology and results over these next couple of slides. Our approach to the project was split between two overarching work streams based on data availability. A shorter time period for a hydroperiod trend analysis, which you can see visualized on the left of the slide, and a longer period for our climatology time series and maps that you can see visualized on the right. We utilized various data sources throughout the project, including NASA's Terra and Aquamodus satellites, the University of Idaho's Gridded Surface Meteorological Dataset, OpenET, and in situ hydroperiod data covering 10 tinajas, complements of our partner Susan Washko at the University of Arizona. The graph on the left highlights findings when comparing a tinaja hydroperiod, you can see the lines in blue on the chart, to monthly average precipitation highlighted in the orange lines. Visually, it is easy to see precipitation spike consistently before the tinaja becomes saturated with water. The graph on the right visualizes some of our results from the climatology time series, highlighting a 3-degree increase in temperature across the monument over the past 40 years. This rate itself is increasing, however, as over the past 20 years, the average increase was 2 degrees Fahrenheit. Both of these rates are higher than overall global rates for temperature rise. Next slide, please. Combining the results from the climatology analysis and the in situ hydroperiod trends allowed the team to determine tinajas at a high risk due to changes in climate. In this map, we have tinaja locations overlaying a section of the daytime land surface temperature change raster. The exclamation point symbols indicate the tinajas we think are at the highest risk for shortening hydroperiods due to temperature increase. In conclusion, the findings of our climatology maps time series demonstrate that rates of warming and drying are increasing rapidly in the Sonoran Desert. Additionally, our hydroperiod analysis demonstrates the feasibility of using climate variables to remotely monitor hydroperiod trends. Further, combining in situ tinaja hydroperiod data with spatiotemporal Earth observations provides a way to highlight tinajas that may be at heightened risk due to warming and drying in the region. These findings can all be used by the National Park Service to inform management priorities and the conservation of tinajas within the National Monument. Thank you.
Great work, Seamus and Susan, and thank you for such a well-composed presentation highlighting this partnership and the project. And another big thank you to all the speakers who talked about the impactful partnerships between NASA Develop and the National Park Service. We will now transition into a hot topic nowadays, the Wildland Fire program, and we are excited to have Dr. David Green give an overview here for us today. So feel free to take it away. Thank you.
Well, thank you, and thank you for the opportunity to describe one of the newest programs on the block, Wildland Fire program, and much of our collaborations. And I'll be highlighting some of the work with our interns from this summer. So next slide, please. So the Wildland Fire program is really intended to look at action across the entire wildfire cycle before the fire ever happens, what happens during the fire, and as the fire recedes, and we are left with a changed landscape. So we're taking an Earth systems approach to look at where those prone areas are, and then what is that fire behavior and the types of impacts that can occur. And as I said, the landscape has changed, the conditions have changed, and we use our Earth observations to understand those implications. In order to do that, we're building collaborations and communities of practice across these three elements of the fire cycle, and working with and across NASA and partners, public, private, philanthropies, to really build out an information network in a co-development approach. And I'll also talk about our collaborations in and across Earth science that we're calling FireSense. Next slide. Well, wildfires are clearly in the news, but in particular, recognizing how they are at an interface between where we live, the natural environment, and our built interface. And that urban interface is one of the most active areas that needs to be monitored, the observations here, but then transformed into information and knowledge that people can use for decision making. This transition of research results and technology to application is the scope of this new program. Next slide. Now, some of the existing tools that have been within the suite of capabilities at NASA and our partners, such as with Forest Service, has been the FIRMS system, an information system for resource management. But we are looking at that in many of the existing tools to upgrade them, to expand them. For example, in the case of FIRMS, recognizing that there are different data sets and also considerably reducing some of the latency of their information because of the timeliness of the decision makings that occur in all those three cycles. Next slide, please. Now, I think you can click once on that. Maybe it does something, or maybe it's fixed. No, okay, go back. So the fire behavior and its impacts. So before the fire and during the fire, as it's changing that landscape, as buildings and infrastructure, roadways and systems are disrupted, we're modeling the prediction of the behavior, the fire extents, the burn scars, and then informing that recovery where the hydrophobic nature of the soils have changed, the slopes have been eroded, and so this idea of behavior to impact to recovery is what we're doing and been putting our story together. Next slide, please. So to reemphasize, it is this connection of data and technology to integrated fire science knowledge to really connecting as an applications program to ones that are use inspired. And as we've indicated, having those partners who are going to use this information and look across this entire time frame, across these landscapes, the human factors, as well as the safety factors that will be gained from this approach. For many, many decades, we've talked about fighting fires, and what our program is doing is partnering with others to move to this shift of really living productively with fires and sustainably in these watersheds and firesheds on local to regional to global scales. Next slide. We're putting this information together in a hub, as well as promoting the collaborations. Next slide, please. We're calling it the Actionable Fire Science Hub. It has all these elements of information going together and is really a clearinghouse and an experimental platform for the community to come together. Next slide, please. It also includes a focus on this aspect of transition to all of the observations, particularly bringing our airborne and our remote sensing together, as well as the in situ and ground information networks. Next slide, please. The collective effort across earth science of ecosystem, atmosphere, technology, and application is what we're calling FireSense. The logo there, I want to say, is the product of one of our keen interns this summer. It's really representing bringing fire back onto the land, the Fire Falcon, our collective efforts and our collective outcomes for living sustainably. So let me finish up here, the next slide. I want to make some thank yous. I want to thank our interns, because as much as they have been engaged in supporting us, they have been an incredible resource of learning for everyone here. Madeline, Maya, Katrina, Vanessa, and Paige will be speaking next on efforts of assessing the scope of the fire-river interactions, wildland fire and indigenous knowledge, getting back to the land, the active fire and tracking with some of the latest technologies and emerging technologies, factors that are making fires into mega fires or of increased concern, but also recognizing the ecology that is going to recover. I want to thank some of the co-mentors here, Jessica McCarty, who's on the call today, Cindy Schmidt, and Liz Wiggins. And one unsung hero, Jennifer Owens from the NASA Intern Program Office, who's been a great help to myself as well as the team. So with that, let's turn to our interns and hear some of their progress and learnings this summer. Thank you.
Thank you, Dr. Green, for that overview of this very pertinent and impactful program. We will now have Katrina, Maya, Janessa, Madeline, and Paige discuss FireSense intern project highlights.
Thank you so much for the introduction. Hi, my name is Katrina Sharonin, and I'll be talking about the state of active fire tracking technology. Next slide, please. So, I just realized this might be the wrong set. My apologies. Is this the correct slides?
One moment, we're getting those pulled up for you.
Thank you. Sydney, could you skip to slide 49?
Yeah, working on it, Lauren.
Okay.
Sorry, I'm not able to see where I am right now. Okay, good to go from here, Lauren?
I guess, Katrina, are these not the right slides?
No, I sent the correct ones in and got them confirmed by Sydney yesterday.
Okay.
Well, maybe because we're already all behind on time, maybe we could skip to the next presenter. And then you want me to share my screen?
That would be great, Lauren, if that's okay. Or do you want me to skip some of these slides, Katrina? And are they a subset or?
Well, I'm not sure where my actual slides are, but
Okay, let's go ahead and skip down to Maya, and we'll come right back to you, Katrina. Is it okay?
yeah, sure.
Great. Thank you so much for your flexibility.
Okay, hello everyone. My name is Maya Seidel, and I'm also one of the FireSense interns this summer, as well as a rising sophomore at McAllister College. And today I hope to talk about the intersection of wildland fire and indigenous communities, a topic that is increasingly becoming recognized as crucial to understand in order to break down barriers and increase equitable outcomes in the field of wildland fire management. Next slide, please. During my internship, I sought to tap into FireSense's potential to help broaden wildland fire perspectives by focusing on its mission to respond to community needs through the creation of different partnerships. And one area that especially caught my attention was the connection of fire to Indigenous peoples both in America and around the world, and what helpful role NASA could play in this context. In particular, I wanted to answer the question, how can NASA rethink our approach to engaging with Indigenous communities? Not only are Native Americans disproportionately vulnerable to wildfires, but many tribes over the course of millennia have developed close ties to fire and understand how to use it to the advantage of both people and the land through techniques like cultural burning. And this controlled lighting of fire has been shown to cut down on harmful fuel loads and promote fire-resilient habitats. It is clear that listening to the teachings and needs of Native American tribes is imperative for deepening our own understanding of wildland fire in our country. Next slide, please. It is this need that brought me to my research project, which focused on synergies and challenges related to reckoning with two very different knowledge systems, those of Indigenous peoples and those of non-Indigenous researchers. I wanted to not only report on the importance of valuing and uplifting traditional ecological knowledge for the program, but to also examine what implications there are for attempting to integrate this knowledge into Western systems of environmental science that groups like NASA have historically operated within. In doing so, I hope that my project meaningfully contributes to the program's outreach efforts and points the way towards increased acceptance and opportunities for collaboration where it is wanted. Next slide, please. The main takeaway I have from both my research and my broader internship experience is that knowledge can't be separated from the people who stand behind it. Indigenous communities breathe life and meaning into their knowledge of how wildfire behaves on their lands and how cultural fire can be used for everyone's benefit. And to disregard this connection would be to misread the full story of wildland fire. And NASA has already been hard at work to avoid that unfortunate outcome, and learning about the efforts of so many researchers across different programs has been so inspiring. I believe that the next step will be to funnel this momentum into the creation of a new framework that ensures that our program's efforts align with the local needs of Indigenous communities and empower Indigenous voices so that we can all work together sustainably. And that is all I have time for to share today, but thank you very much for allowing me the opportunity to speak and share a bit about my time with FireSense. Thank you.
Should I go ahead? Or is Katrina's ready? Yeah, please go ahead and we'll circle back to Katrina. Okay, hi everyone, I'm Vanessa. I'm going to be talking about factors exacerbating megafires and increased fire intensity. This summer, I documented the fire community's needs, opportunities, and uses of NASA data. I also conducted a focus project on vegetation moisture averages by species to use deviations as an indicator of fire potential. Logistics for that proved more challenging than I expected, but being at NASA, I can document the challenges and needs and find solutions. I'll now share my work as it relates to megafires and increased fire intensity, which just encompasses the general increased fire behavior, which is going to vary by region, but generally that's what I'm talking about in the Western US primarily. Next slide, please. One of the biggest barriers in fire is not tech limits, but the public misperceptions and opposition to prescribed burns. Media and public discourse suggest that climate change is the main driver of increased fire severity, when in fact it is more complex. I made an interactive flowchart to show the complexity behind increased fire intensity and how to reduce risk. The next slide, please. Fires and increased fire intensity. I've created some categories of drop the audio. Oh, I didn't know I narrated. Okay, so here's a, is it possible? Yeah. Here's a draft of my flowchart. Many factors such as vegetation stress, extreme fire weather, and are the categories, and then that's broken down into specifics. The arrows represent interactions. Dashed lines note impacts from increased fire severity. And clicking on a box shows you more information as well as data sets from NASA and other sources useful for monitoring that topic. Thankfully for legibility, PowerPoint lets you zoom in, but makes you zoom out to click on the boxes. It can look a little daunting, so I may migrate to a better platform if I can find one. I don't have time to detail all of these boxes, but next slide, please. I would like to highlight, and if you could hit play, it should be no audio though. I'll highlight a need I hear a lot, a fuel model for the built environment. This is a burn probability data layer, red indicating highest burn probability, and it shows no burn probability in cities, not because they're fireproof, but because there's no accurate way to predict fire behavior in urban areas, as made clear by these images and VIIRS hotspots, which are the various colors. They're irregularly located. Hotspots would be like the purple and the yellow, and then the smaller dots are the building damage status. The Alameda Fire in southern central Oregon near Medford destroyed over 2,000 homes in just a few hours. Unfortunate incidents such as the Alameda Fire, Camp, Tubbs, and Marshall fires, among others, are providing data on structure damage, but we lack fire spread data in real time, which would be useful both for assessing the potential spread in real time as well as retrospective analysis to determine what factors are influencing that spread. So high resolution fire detection data is something that I've heard a lot of requests for, both spatially and temporally. This may be unrealistic via satellites due to lead time, cost, spatial temporal trade-offs, and risk of collision with space debris. But an airborne vehicle that could hover over a fire is an idea that a lot of people have suggested to collect the hotspot data so we could model rapid fire spread and identify ways to reverse the trend of entire towns being destroyed through improved urban design. I don't know how to make this aircraft a reality, but I hear a lot of people wish for that. Through my projects this summer, I became more familiar with NASA data, limits, opportunities, and needs in the fire community. I'm also no longer storing all of the interactions of fire in my head, so I can focus on the minutiae of subsets, such as vegetation moisture, and hopefully someone else finds it useful. Thank you.
Thanks, Vanessa. Hi, guys. My name is Madeline, and I'm going to be talking about assessing scope and need through fire-river interactions. Next slide, please. So I've been thinking a lot about the overlap between fire sciences and fluvial or river sciences. These are two different fields, but there's always interaction and overlap in science. So I set out to catalog that overlap, and it turns out there's actually quite a lot of it. I have a little list of a bunch of different types of, ologists and other scientists and researchers who all either play a role or can play a role in developing and spreading more knowledge of these interactions. But this on the right here is just one of my favorite examples to give you an idea of what a fire-river interaction can look like. So this is an example of beaver dams contributing to localized fire resilience. The beaver dam, because it dams the river, locally floods the banks, which provides water to vegetation that probably wouldn't otherwise have it in a dry season. And then when a fire rolls through, it doesn't have access to that fuel right alongside the river, which insulates the river itself and protects the banks. This prevents ash from getting into the river, which preserves the quality of the river, which is important if there are people relying on that river for drinking water. And it's also important for the river ecosystem, so fish and algae, and also the beavers themselves, who would be, hurt by an active fire and the ash and sediment left behind from it. So that's kind of a fun example of how these interactions can play out in the real world. And this one, the one of beavers, has been really well studied, but throughout my time in my internship, I've identified certain areas where there are some gaps in the research, particularly when it comes to river morphological recovery after a fire. A lot of the current literature focuses on water quality, which makes sense because it's very high impact. But moving forward, we're going to have to, fill in these gaps to have a complete understanding of what's going on. And this particular study from the picture actually used a lot of Landsat imagery. So I started asking the question, where does NASA fit into this field of research? Obviously, we have a lot of great imagery like Landsat and a lot of great researchers and scientists, but as a large organization, is there a different, more involved role that we can play in this? Next slide, please. I was able to answer that question at the Esri User Conference in San Diego last month, where I, along with Vanessa, who you just heard from, and Paige, who you're about to hear from, were able to help spread the word about this actionable fire science information hub. The AFSI Hub, as David touched on just a few minutes ago, is being developed as a centralized location for all things fire science. So that's pre-fire, active fire, and post-fire. We hope that this is going to include data sets, analytic tools, resource guides, FAQs, technology user courses, maps, all publicly available for people who are impacted by wildfire, which, as we note a lot in the fire science community, is everybody nowadays. By talking with stakeholders in the fire world and gathering live feedback from potential users of the hub, Janessa and Paige and I learned that NASA can play a large role in spreading the word about this data and the tools that are out there. There's really so much good science out there and so many good tools, but it has a much smaller impact when nobody knows about it or knows where to find it. Next slide, please. Throughout my research, with FireSense and at the Esri User Conference, I learned how science problems are never really one-sided. There's always more perspectives to include in the conversation, and there's always more work to be done. And I've been really happy and excited to see that NASA scientists are always learning from each other, not just at NASA, but with the entire community. So thank you. And with that, I'll pass it on to Paige.
Hello, my name is Paige Worth, and this summer I've been focusing on fire ecology and a safe return of fire to the landscape. Next slide. With all of the recent destructive megafires that have been happening, it's pretty easy for the public to forget that in some capacity, fire is naturally present in all ecosystems, and emulating natural fire regimes is necessary for ecosystem health. And one of my projects this summer was to look at the sagebrush ecosystem's relationship to fire. I made a story map with information about the biome's historical versus present fire regimes. And the sagebrush ecosystem historically does not burn frequently, but human-induced changes are causing more frequent and more severe fires in the biome. The story map has an interactive portion, which is the part that's shown here, and it shows every fire perimeter between 2000 and 2020. These perimeters are from or based on MTBS data, which is based on Landsat data. And on the map, you can sort by different variables and see the trends over time. The idea for the story map is to be just a landing page for anybody who is researching or just interested in fire in the sagebrush ecosystem, and it serves as a summary of the topic and links to a lot of other studies and resources, both NASA and externally from NASA, on fire and sagebrush. And my goal going forward is to create other story maps that summarize fire in different ecosystems so that we can cover the rest of the US in an educational way. Next slide. The second part of my theme was to look at returning fire to the landscape where it would be beneficial. I wanted to focus on private landowners who burn less frequently than public land managers, and as a pilot, I chose Texas, which historically overall has a relatively short fire return interval and about 95% public land ownership. I created a map, which is the one that you see here, separated by county that has the average fire return interval, the regional contact for the private landowners who wish to conduct private burns on their land, and whether there is an active burn ban in the county presently. This map is embedded in a larger story map that has resources like prescribed burn templates and best practices and land preparedness. And this is still a work in progress. I'm hoping to add a little bit more NASA data to the map to help landowners understand the ecosystem that they live in and the natural fire regime in their area so that they can use the resources available in the story map to create a healthier landscape overall, both for their own safety in avoiding larger wildfires and for the ecosystem's health. Once this tool for Texas is complete, I'd like to move forward in other states until they're all covered and it would be available for any private landowner looking to do a burn in the United States. Next slide. Quickly pivoting to my takeaways, this was me at the Esri conference. This summer, I've talked with a lot of people within the world of fire science, and I've been able to see how interconnected the community is. Everybody has a stake in fire science in some way, and since we're all stakeholders, it makes collaboration really natural. Since fire science reaches so many corners of our lives, we need to be sure that everybody that's within this community feels heard and represented in the science that they need to achieve their goals and to live safely. Thank you.
You. Sorry about the commotion with the slides. So today I'll be talking about the state of active fire tracking technology. Next slide, please. Okay, so active fire tracking technology deals with the need to real-time monitor fire behavior. So this comes in the form of fire perimeters in burned area. So big agencies in the field, including CAL FIRE and the Forest Service, use several methods for perimeters, hand-drawn maps, GPS walking and driving, infrared flights. But with each method, there's a lot of challenges. It takes a lot of time, it's costly, it's inconsistent. And so NASA has come in with some research to try and produce results to aid perimeter creation and tracking. However, next slide. There is a need to match and understand how well our tools perform regarding agency standards. Agencies such as CAL FIRE really need to continue expanding their methods. And so, sorry, fumbling. I created a software program in collaboration with the scientist Liz at Langley, which helps put our NASA products, such as VIIRS, into the same environment as agency data in order to understand where we need to change our technology and improve it to help agencies. We have our own idea of success, but then we also have agencies who have their own needs. And so this environment helps us understand where we fail and where we succeed in terms of agency terms. We're speaking their language. So this software program helps to compare our technology in areas such as radiative power and magnitude, location and range for our detections, missing detections, and so on. So the right shows an example of the program. It's a very visually based program, but there's other statistics produced. Next slide. So this program, for example, produces an infrared magnitude comparison with infrared flights. Infrared flights are a very big method used by major agencies. And so if we can compare our technology to this method, we can learn a lot about where it succeeds and fails in terms that CAL FIRE understands. So on the left, there is intense and scattered heat categorization by an infrared flight, NIROPS. And on the right, the program which we're working on pulls the nearest time VIIRS nearest flyover time of VIIRS and overlays it, and also colors by the magnitude. And so just looking at the diagram, it looks like the magnitude lines up with intense heat. The intense heat corresponds with the higher magnitude points. Not shown here too is that the program calculates the average FRP magnitude, and it shows that in intense heat areas, VIIRS is picking up a higher FRP magnitude. Next slide. Additionally, the program also overlays alpha shapes, which is an algorithm that is used by some scientists at NASA that mimics the perimeter using the remote sensing points. And so just overlaying it, we can tell that there's some errors with the shapes. And so although it may seem obvious, giving a number to it and visualizing it is critical for all of the agencies. CAL FIRE and the Forest Service can understand where exactly we succeed and where we fail. And from there, we can improve our collaboration. Next slide. So there were lots of details going over and the program is still growing, but overall, I've learned a lot about agency methods, about perimeter creation, and also learning about NASA's active fire tools, their limits and capabilities. And so with all this project work, what we need to do is that we need to talk with our stakeholders and show them where our technology is working and where it's not relative to their standards. If they can understand, hey, we have our infrared flight here and we have VIIRS here. VIIRS seems to do well here with infrared flights, but doesn't seem to match the quality of infrared flights here. We can better understand where we belong. We're not meant to replace CAL FIRE or the Forest Service. We're meant to work with them. And so this project hopes to accelerate more of that comparison and conversation. Thank you.
Great, thank you all. It is great to hear all the wonderful work being conducted through the FireSense intern projects. Also, a big thank you to everyone on the call today joining us for the first half of the session. It has been my pleasure to introduce our speakers and also guide you through these important NASA Earth Science applications, projects, and partnerships. Guiding you through the second half of our session today will be my friend and colleague Sarah Hedema at our NASA developed Colorado location. Thank you again.
Hi all. Technical difficulties always. I was unable to unmute myself, but welcome to our second part of day 2 of NASA Earth Science Application Week. So for this session, we will be highlighting some of the climate and water resources application areas. So my name is Sarah Hedema. I am a fellow with the NASA Develop program, and I am based out of Colorado State University in Fort Collins. But you are not here to learn about me, or here to learn about all of the climate initiatives that are happening. So I am going to pass it off to our first presenter. But before I do that, just a few reminders. Just please remain muted. And then if you have any questions, you can post those in the chat. And then also just bear with any folks, as there are sometimes technical difficulties in the virtual environment. But for our first talk, I will pass it over to Allison Leaner to talk about the climate and resilience application areas.
Thanks, Sarah. Can I just confirm you can hear me? We had some great. So first of all, I'll start off by saying thank you. And I am positive that we're all really excited to hear from the Develop team, as really evidenced by these amazing projects that we've been hearing about. My name is Allison Leidner, and I'm the program manager for the Climate and Resilience Applications area. Some of you may recognize me from some other roles that I've had at NASA, including the program manager for early career research and GLOBE, as well as roles I've had with the biodiversity program and the National Climate Assessment. We can go to the next slide, please. But before I delve into this new program area, I wanted to start by taking a step back and talking about climate at NASA more generally. In the Earth Science Division, we've made enormous investments in the observation systems, technology, research, data systems, and applications that help us understand how and why climate is changing, and what this means for our planet, and how we can adapt across all systems on the land, in the water, in the air, for plants and animals, and of course, for people. Understanding and informing adaptation to climate change, though, isn't something that's just for our Earth Science Division. It permeates work across our entire agency. NASA's research centers, facilities, and assets are and will continue to be impacted by a changing climate. This bottom picture depicts Kennedy Space Center, and NASA's Office of Strategic Infrastructure has a master planning process and resiliency planning process that takes climate change into account, and our Earth Science Division works with them on these activities. NASA also makes investments in advancing aeronautics research to reduce contributors to climate change. And at the end of tomorrow, you'll be hearing from Dr. Kate Calvin, NASA's chief scientist and senior climate advisor. That's a tough one to say sometimes. Can we go to the next slide, please? So now I want to go into this new climate and resilience applications area. The program is what I like to say is under development. At the really big picture level, we're looking to address the use of earth science capabilities to inform policy analysis and business decisions related to climate factors. It will support public and private sector decision-making using earth science data and models to reduce risk and build resilience in integrated human and natural systems. And as we know from a lot of work that's been done here in the US and around the world, looking at the intersection of these human and natural systems, like this picture on the right, is really critical to understand how we can build resilience to climate change and how we can inform policy analyses that may affect our future trajectories. But this is a lot, and we know that climate and resilience are really broad-ranging topics. And as you've heard throughout this week, many of our programs and projects incorporate climate change and resilience into their work. So if we go to the next slide, what I'm working on now is identifying a niche for the program to determine where there are opportunities to apply NASA insights to address climate and resilience topics in areas that NASA Applied Sciences is not currently working in. And to do this, I've had a lot of conversations and have done a lot of listening in the public and private sector to build an understanding of what stakeholder needs are and where climate-related services can be enhanced. And I wanted to give you an example of one conversation that I've had with Rachel Barlock, which is informed by thinking. Rachel is a planner at the Southeast Michigan Council of Governments, or SEMCOG, And SEMCOG itself is a regional planning partnership of government units in a 7-county region of Southeast Michigan that serves millions of people. And one topic of interest among these regional councils of governments, and her council of governments specifically, is understanding how future climate change will impact infrastructure, and therefore what investments they should be making in infrastructure now. And they think about this a lot when it comes to transportation systems and stormwater management systems. And so understanding these concerns about how the current trends impact their infrastructure, thinking about where those investments are for their future, and understanding how they've used NASA and other Earth observation data to inform their thinking has been really helpful for thinking about these investments that pertain not just to thinking about an individual event and an individual heavy rain event, but really thinking about the trade-offs involved of building systems that have a certain capacity against the financial realities of today, and where these governments have to make those balances in a very complex landscape. And so I just found that these types of conversations have been really illuminating. And I want to give you an example of another project that we're funding that's being led by Dr. Julie Vano at the Aspen Global Change Institute. And her team is assessing climate information supply and demand to identify areas where NASA observations, models, and knowledge can inform decisions in numerous sectors. And some of the sectors that that group has been thinking about, as well as me, are infrastructure, coastal resilience, climate information systems, climate services, scenario development and analysis, greenhouse gases, and energy infrastructure. And so I hope this talk has just given you at a very top level a taste of where this climate and resilience program fits within a larger investments that NASA and commitments that NASA has made to understanding our climate, and where we are trying to fit this new program in when there's an enormous demand and enormous need for climate related information and services, and how this program can fit into that niche in a way that complements the amazing work that you've been hearing about this week from our developed team, as well as from a lot of other applied sciences programs. So with that, I know we've gotten a little behind schedule. I hope I can help regain a few minutes and turn it back over for our next speaker. Thanks.
Thank you so much, Allison. So next we will hear from Dr. Emil Charrington and Christine Evans, who will give an overview of the SERVIR-Carbon pilot.
Yeah, thank you so much, Sarah, and of course, Dr. Leitner. And just to say that along with my colleague, Christine, we'll be talking about a new initiative that we're doing with SERVIR. Next slide, please. And also just to say, really briefly, earlier my colleague Kelsey Herndon spoke about the work that SERVIR Amazonia is doing, but just as a refresher for people, SERVIR is a partnership between NASA USAID and leading geospatial organizations. We have hubs in 5 parts of the world, in South America, in Africa, and in Asia. And we do a lot, not just in the areas of land cover, land use and ecosystems, but also in weather and climate and other thematic areas listed there. Next slide, please, just in the interest of time. One thing to mention, as Kelsey was speaking about the mangrove service being implemented by SERVIR Amazonia, one thing to note is that actually with a number of SERVIR hubs having been in operation for over 10 years, land cover has really been the bread and butter of what SERVIR has been doing. We heard the earlier talk on the legacy of Landsat's 50 years. Most of the SERVIR hubs have been working with Landsat data for a very long time and have been doing a lot specifically in the areas of land cover change. And while this talk will just kind of scratch the surface on what we're now starting to do, one thing to highlight is that this activity really dovetails with another activity being led jointly by my colleague Africa Flores, and also by one of our SERVIR applied science team PIs, Professor Stephanie Spera, regarding intercomparing different land cover change algorithms. Next slide, please. And so just briefly in terms of kind of the what we're trying to do and the why, just this bigger idea, you just heard Dr. Leitner's talk, this increased attention to climate change mitigation and resilience activities. Yesterday, we heard Dr. Arji Kavada speak about the importance of the Sustainable Development Goals. And just to say that this work that we're doing is the idea is to kind of step step forward from the different severe land cover services that are already in development, and to take them from land cover into estimates of carbon stock and carbon dioxide emissions estimations. And we're implementing it in one country in each of SERVIR's focus regions, so 5 pilot countries. And again, Christine in a wee bit will kind of get us into the weeds of some of that. And so next slide, please. And then just overall, just to say that what we're seeing here is a graphical abstract, as it were, of a document that we commonly use across the SERVIR network, and it's called a theory of change. And the idea being, if we look at the column there that says inputs, that second column, where there are just so many different Earth observation data sets present, how do we put those together and kind of get towards what Lawrence spoke about yesterday in his remarks, as well as today, in terms of impacts of Earth observation data, and specifically how can we, through the work with USAID and our hubs, get at helping countries to do a better job in terms of their carbon dioxide emissions. And so with the next slide, I will pass it off to Christine to get into some of the cool details. Thank you.
Thanks, Emil. So for this project, we are creating a carbon emission estimate ensemble. To solve the emission equation, we need area of change and carbon stock. So for our change area, we have a mixture of global land cover data sets, regional data sets provided through our hubs, as well as change detection algorithms. Each of the land cover activity data outputs were combined with each of the listed above ground biomass data sets in order to calculate carbon stock within the deforested regions. With these two variables, we use the emission equation at the bottom right of the chart to estimate our final emission value. And those values were added to our ensemble, where we compared each combination of carbon emission estimate to determine the best data sets, as well as compare those values to what was reported in each country's SPREL reports. Next slide. Here you can see some examples pulled from our ensemble. With just 4 calculations per country in the charts, you can already see there's a large difference in emission estimates. So for example, looking at our Bangladesh chart, a combination of RLCMS land cover with the 2020 geocarbon biomass estimates much lower emissions when compared to the JAXA and SACHI combination. While these charts are only a few examples, each country has approximately 20 to 30 different combinations. All of the outputs are not only compared to each other, but then also compared to what the country itself is reporting. Developing country parties who implement REDD+ activities submit a national forest reference emission level report every few years, where they document their forest activities along with the resulting carbon emissions. So we've taken this information and added this to our ensemble. So on the bottom left is an example from Bangladesh, where you can see the document is reporting approximately 820,000 tons of emitted carbon per year, which compared to our chart of remotely sensed data falls on the lower end of that spectrum. Next slide. The final part of our analysis is to bring in land cover change detection algorithms. We began using these algorithms in our global intercomparison project that Emil mentioned, where we work with our hubs along with the developers of these algorithms. So it's Shishwan Chen for CCDC SMA and Dr. Robert Kennedy for Landrinder. And we are working to find the best parameters to use for these algorithms in each country. Next slide. So in general, this project is targeted to improve the understanding of carbon dynamics on both a national and regional scale, while highlighting the U.S. government support for climate change mitigation activities. Yesterday, we heard about Sustainable Development Goals and our use of remote sensing to address those. And this project addresses SDG 15.2, which promotes the sustainable management of all types of forests and halt deforestation. It also addresses the Glasgow Leaders Declaration to conserve forests and accelerate their reforestation, as well as USAID's Global Climate Change Program's goal of reducing greenhouse gas emissions from deforestation. Next slide. So moving forward this project, we are working with a technical assessment group, including Dr. Laura Duncanson from the NASA JEDI project, Dr. Stephen Ogle, a co-author on the IPCC guidelines for national greenhouse gas inventories, and Dr. Pontus Olofsson of NASA Impact. And they are providing their expertise on our methodologies and results. We're also working closely with the severe hubs to build their capacity on emission estimation, as well as integrate our outputs into their existing land cover services. We've begun discussions with NASA Develop to plan a couple projects implementing our methodologies. And finally, we plan to have a prototype of an internal platform where users can integrate their own land cover and biomass data sets and estimate their own ensembles. Next slide. So to summarize and finish out the presentation, we want to highlight the who, what, why, and how of SCAP. We are really utilizing the entire severe global network to combine the thematic and regional expertise available to us. The pilot countries within our hubs are already working with land cover products, and it's a simple transition from land cover data to greenhouse gas estimation. So we want to support the integration of emission estimation into these practices. This will also support the hub's integration in REDD+ reporting and provide guidance that is consistent with IPCC's good practice guidance. So we realized this was a lot of information and it really only scratches the surface of our project. So if you would like to learn more, please feel free to reach out to Emil or myself. And then we also have a presentation at the upcoming PCOR conference and hopefully at AGU in December where you can catch us and learn more. Thank you.
Thank you, Emil and Christine. Next, we're going to have Ian Lee and Connor Reset present on Hawaii climate.
Thanks, Sarah. Hi, everyone, and thank you for coming. My name is Ian, and together with my teammate Connor, we will be presenting our Arizona Node project on Hawaii climate that our team, with the support of our advisors, have been working on the past 10 weeks. As global mean sea levels continue to rise, Hawaii faces ever-growing threats from more frequent flooding, wetlands encroachment, and loss of important heritage sites. To support local adaptation and mitigation efforts, our team utilized NASA Earth observations to assess wetland extent and coastal sea level rise inundation risks on Hawaii Island. Slide, please. Our team at NASA Develop partnered with the County of Hawaii, the State of Hawaii Department of Land and Natural Resources, DLNR, and Arizona State University for this project. The county and DLNR are currently developing a shoreline setback plan and climate action plan targeting high priority areas of the island to focus their mitigation and adaptation efforts.
There are three main objectives to our project. First, to obtain better knowledge about wetland extent in Hawaii, we created a wetland extent map using the Wetland Intrinsic Potential Tool, or WIP for short. Second, to combat flooding caused by sea level rise, we modeled short-term flood inundation risk areas along the coast of Hawaii by building a machine learning model. Third, we calculated a ranked risk approach to indicating areas around the island of Hawaii at the highest risk of sea level rise. Our project provided an insight into the publicly available tools and Earth observation datasets that can be used to leverage partner and stakeholder decision-making processes. Next slide, please. The WIP tool is used to derive a probability raster of wetland extents and locations. This tool utilizes the predictive power of random forest machine learning algorithm to predict wetland locations based on the training data and relative input variables. We use 6 different ancillary data sets from hydrologic, geologic, climate, and topographic variables to derive 22 raster inputs. Training data was derived from the National Wetlands Inventory and the small amount of local wetland data that was available from the county. All models were tuned to achieve an out-of-bag error below 10%. This means that each model performed with a 90% accuracy or greater of predicting wetland and upland locations based on the provided training data set. One of the statistics outputs the WIP tool generates is a variable ranked importance metrics, and soils data variables and climate data variables continuously ranked highly for all models. While unexpected after some local insight, it is not surprising to see these variables ranked so highly given the dynamic variability in them from the east side of the island to the west side. The large wetlands shown with high probabilities in the north and northeast were confirmed by project partners to be a large bog in the north and a consistently very wet forested area in the northeast. This local verification bolstered our model performance confidence. Next slide, please.
To address coastal sea level rise, we performed a feasibility study on using machine learning to classify flood risks and to determine the factors or features most influential to flooding. We decided on a random forest model as it is able to capture non-linear relationships and is robust to overfitting and outliers. We built our random forest model from scratch and relied on literature and discussion with experts to select 6 features that had sound physical reasonings to affect flooding, and these features are shown in the chart. For our label, we generated flood risk indices for 5 known flood events in Hawaii from 2019 to 2021. Our tune model achieved an average 90% classification accuracy and 10% out-of-bag error on the 5 flood events, with sea surface temperature anomaly and precipitation consistently ranking as the most important features. Our results support the feasibility of a local scale model and can guide feature selection for future flood risk studies. We generated a short-term flood risk maps from the 5 flood events and observed higher flood risk primarily on the windward side. For future work, our model can be updated with more data, including additional features like wind, and breaking down existing features into sub-features like sea surface temperature anomaly to currents and thermospheric expansion, further refining our understanding of what influences flood risk. Thank you for listening.
Thanks, Ian and Connor. So next we're going to have Melissa Ashbaugh and give an overview presentation of the Wichita Climate Project.
Hello, my name is Melissa Ashbaugh, and I'm part of the Wichita Climate team within the Virtual Environmental Justice node at Develop. And today I'm going to be presenting our project using satellite data to identify neighborhoods vulnerable to extreme heat for equitable climate mitigation and planning. Next slide. The goal of our research was to identify areas of Wichita, Kansas, where residents are most at risk of negative impacts from heat. To guide our project, we took inspiration from the principles of environmental justice developed during the first National People of Color Environmental Justice Summit in 1991. Specifically, we focused on community collaboration, seeking justice and transformative change, bringing mutual respect to the center of all of our interactions, and addressing systemic oppression in our analysis. We also tailored our research to the goals of our partner, the City of Wichita, and the wider Wichita community. In the words of Nina Rasmussen, the City Environmental Quality Specialist, over the last decade, Wichita has experienced consistent tree canopy loss alongside rising temperatures. We realized heat in a changing environment could pose a risk to our residents. City staff did not have the expertise or equipment to identify localized areas of high heat, and this project allows us to learn more about Wichita's urban heat island effect and those most vulnerable in order to make equitable decisions for a resilient future. Not only will this work be integral to formulating climate adaptation and mitigation plans, but it will also serve as a powerful teaching tool within the Wichita community. Next slide. We had many deliverables for this project, but the 2 that I'm focusing on today are our tree canopy and risk maps. On this slide, we have our high resolution tree canopy map in the oval, which we built using PlanetScope imagery. On the right is a map with tree canopy cover aggregated by census tract. These maps show an unequal distribution of tree canopy in the city. Tree canopy is particularly low in southwest Wichita, and we found that areas of highest heat exposure also have the least tree canopy cover, which is unsurprising given the known cooling effects of trees. Additionally, we found that our tree canopy cover classification identified 20% more tree cover than the National Land Cover Database, a standard canopy mapping tool, meaning that our data is a helpful resource for the city to track their tree canopy and identify areas in need of additional planting. Next slide. The map on this slide shows heat risk by census tract. We identified 17 high-risk census tracts displayed in dark purple, which were considered highly vulnerable by the Centers for Disease Control and had high average temperatures. High-risk tracts circle the city center in areas home to more socially vulnerable populations and near enough to the dense urban center to feel significant urban heat island effects. People living in these areas are most likely to suffer negative heat consequences. Of the 17 high-risk tracts, 82% were also categorized as environmentally disadvantaged by the Council on Environmental Quality's Climate and Economic Justice Screening Tool. The tool is part of the Federal Justice 40 initiative, which aims to provide 40% of the benefits from federal programs to disadvantaged communities. And this means the majority of the high-risk tracts in Wichita will also be eligible for Justice 40 investments. Together, our maps provide context on why some areas are hotter than others, identify areas of Wichita most likely to experience negative impacts from heat, and will inform the City of Wichita's heat mitigation efforts, such as tree planting and maintenance, cooling center siting, and targeted programs to manage energy burden. And that's all the time I have for today. Thank you very much.
Thanks, Melissa. So next we are going to transition to our water resources portion of today's session. So first, Sarah Brennan will introduce the water resources application area and the WWAO.
Great, thank you very much, Sarah. So good afternoon, everyone. It's an honor to be here today and a true pleasure to listen to all the fantastic presentations yesterday and this afternoon. As Sarah mentioned, my name is Sarah Brennan. I'm the Deputy Program Manager on behalf here today of Brad Dorn, who is the Program Manager on leave. I'm going to give a brief introduction into the Water Resources Program, which includes the consortia focused specifically on Western water challenges, the Western Water Applications Office, acronymed as WAO, as Sarah mentioned. Next slide, please. Oh, sorry, previous slide. Thank you. So Earth observations provides a very unique perspective on Earth's water resources. Satellites and airborne campaigns can provide consistent data on water aspects like precip, snow cover, groundwater, soil moisture, and water quality, really just to name a few. This consistently collected record of data and information over large swaths of land and over long periods of time can provide water resource managers with data that is simply inaccessible by in situ measurements or sparsely measured areas. It is a significant piece of the puzzle on which resource managers and decision makers make critical decisions. So at the very basic level, when I'm talking about the program, I like to start with why. Why does NASA have a water resources application area? On the surface, it seems relatively straightforward, that satellites collect data and make that data available so others can access and use it. But for integration into an already established decision-making process of a partner organization, it's not that straightforward. The Applied Sciences Program's mission, as Lawrence mentioned earlier this week, is to apply insights from Earth science to benefit the economy, health, equality of life, and environment. And this goes well beyond providing data. It's us understanding user needs and requirements, understanding partner decision processes, and working with them collaboratively to identify the opportunities and value that Earth observations can bring to their work. It's building trust and showing value to ensure long-term sustained use of Earth observations in their work, and it's our responsibility to demonstrate the value of Earth observations and increase the adoption of EO by making it more accessible in a digestible, informative, and usable format. Next slide, please. So what drives us? Well, there's clear evidence that the community, from the community showing that there's value and need for this work. Impacts driven by Earth observation information have ranged from the very specific, such as in the case of E&J Gallo, reducing their irrigation by up to 25%, or by pinpointing source pollution in the Tampa Bay. That range continues to the value provided through a partnership that relies on Earth observation data to provide regular and consistent data insight into a situation, such as the drought over a large spatial scale, like with the California Department of Water Resources. And the range of program impact also includes examples such as increasing accessibility, like with the soil moisture information that is now accessible at the field scale to farmers across the US. Next slide, please. Throughout the event already, we have heard terms like user-centered and collaborative, because it really is at the crux of the Applied Sciences program and the foundation to many of our activities. Within the Water Resources application area, we have established and built upon trusted relationships. Many are long-standing, like with the USDA, the American Water Resources Association, and with California Department of Water Resources, while others are new to the Applied Sciences water community, like the North Carolina Department of Health and the government of Peru, which are now engaged with the recently awarded applied research grants. Regardless of new or long-standing relationships, each engagement starts with the same discussion question to the partner. What is the challenge you are seeking to solve? Rather than us, NASA, saying, we have what you need. Next slide, please. So from a programmatic perspective, we enable this work through 3 pillars of the application area. All three pillars aim to explore technology and capabilities, connect the science to the decision makers, and increase access to information. I'm showing you this today because I often get asked, how do WAYO and the Water Resources Program work together, and how can someone engage with each? Next slide, please. So first we have our portfolio of applied research projects. These are competitively awarded grants that fund projects for 3 to 5 years through the NASA ROSA solicitation process. At any given time, we, the Water Resources Program, has about 20 to 40 projects that are being funded with PIs and project teams all over the globe that are exploring how Earth observations can contribute to the knowledge base used for critical water resources decisions. This can include monitoring water quality from space. Oh, can we go back one slide, please? Thank you. This can include monitoring water quality from space and more accurately estimating snowmelt, runoff, and stream flow, understanding ET rates from the field, or understanding shifts in groundwater mass and aquifers. This pillar supports individual applied research that may include application exploration and development, capacity building, or transfer of technology and information to partners. In 2022, we just selected 30 new projects to fund. The new projects are bringing in new stakeholders into our community, addressing topics like water quality monitoring, measuring surface water extent, and exploring seasonal to subseasonal forecasting. Next slide, please. We all know that water is managed locally. One river basin's needs are very different from another's, and more so, access and management of this precious resource is unique to the Western US. So in 2017, NASA and the Water Resources Application Area set up a specific office focused on addressing the unique challenges of water management in the West. Their mission is to improve how water is managed by getting NASA data, technology, and tools into the hands of managers and decision makers. They do this by first identifying needs in Western water management for information decision support through formal needs assessment workshops. And they're going through this process by basin, touching every Western state. After conducting the workshops, a report synthesizing the findings is available publicly. WAYO then builds and supports projects tailored to meet those needs, engaging with stakeholders from beginning to end. Next, WAYO aims to make connections between stakeholders and NASA scientists. And finally, they focus on the process and effort of transitioning water applications and technology into an operational, sustainable state for long-term impact for Western water managers. Next slide, please. WAYO is also leading the presence of NASA in the communal efforts to mitigate the impact of drought in the Western US. On WAYO's website, you'll see a collection of all of NASA's work that contributes to our knowledge about drought. Go there to see how NASA improves drought monitoring, including forecasts and early warning, supports drought management and scenario planning, improves water supply forecasts, and informs efficient water use practices. And finally, I want to call out WAYO's work on the transition of research to operations. Sustainably transitioning a NASA-developed product like OpenET or CropCasma is challenging and requires a lot of moving pieces. WAYO is leading the charge in applied sciences and at NASA to really understand that process and identify streamlined pathways for transitioning water applications and technology into an operational, sustainable state for long-term impact. For this, WAYO builds and transition plans from project inception, develops partnerships with government agencies or public-private players who can assume ownership of the end products, and provides all projects with expertise in technology transition and business management. Next slide, please. Our third pillar consists of all the activities carried out by the Water Resources Program Management Team. Brad, myself, Forrest Milton, John Bolton, Christine Lee, in addition to the leadership of WAYO and Johnny Graysick, Forrest, and Stephanie Granger. This pillar enables us to carry out elements that are captured in the other two pillars, that aren't captured in the other two pillars. This is where we continually assess and build out our program priorities. For the near future, we are focusing on increasing partnerships and engagement with private sector entities. We're also focusing on building out our presence and leadership in the field of water quality monitoring. And as you're going to hear in the next presentation by John Bolton and Perry Otto, we're developing an international water strategy that will best support our international projects and develop a plan for strategic engagement with international partners. So if you'd like to be involved or contribute to any of these activities, please reach out. Next slide, please. So hopefully at this point, you're asking, how do you learn more? How do you get connected and utilize or build off all this great work? Next slide, please. First, get connected. Tap into our community. The Water Resources Program has a listserv you can join, and there's a WAYO newsletter that goes out on a regular basis. Encourage other voices to join the discussion, and most importantly, advertise and communicate and be an advocate for your work and each other's work. Next slide, please. Second, access, explore, and utilize all the data, resources, and tools available to you. There's a lot of NASA data available through NASA Earth data sites, and you can explore visualization tools like Earth Information System Pilot on Freshwater. The resources through RSET, the Applied Sciences Guidebook, and Water and Agriculture Pathfinder resources will guide you through how to use these resources and information. But as we discussed, we support products, resources, and information that is specifically tailored for end users such as Floridian Water Utilities, the Central Arizona Project, Vineyard Use, and the Mekong River Basin Commission. However, many of these tools are available for you to access. For tools like Cyan, Crop CASMA, the Global Water Monitor, OpenET, and soil moisture information that's available on Google Earth Engine. You can sign up, explore, use, learn from these tools, and build off these for your own research. Next slide, please. And finally, drive the future of science, the future of this community, the future of the program. Submit needs and ideas by contacting us through the Applied Sciences website or through the WAO website, which has a water management needs page you can submit ideas to. Lead research and also speak up. You can always find our team or individuals supported by our program at these events like AGU, PCORA, AMS, World Water Week, and any AWW or AWRA meetings. Most importantly, contribute to the conversation, or better yet, lead the discussion on the value of Earth observations. So in closing, next slide, please, thank you. I just want to mention before we go, to make sure everyone is aware that in addition to what we already have for water resources information, the next decade is exciting with the launch of these satellites that will provide unprecedented information on water. And I know I'm out of time, so I'll simply go on to the next slide to say that there are some really fantastic presentations coming up after me. I'm looking forward to hearing all of them. And then with the last slide, this is the team that you can reach out to if you have any questions or if you want to get engaged. Thank you.
Thank you, Sarah. So next we have John Bolton, Perry Otto, and Artie Aurora. They will be presenting NASA's International Water Strategy.
Thanks, Sarah. Well, that was a perfect segue into our discussion here. So we're going to be talking about the Water Resources Program International Water Strategy. And what this is a new initiative that arose from the Water Resources Program that is in response to new U.S. government policy directives. And as you've just heard from the climate program, examples from Sarah and others, water is very important. Water is everywhere. So what we've done is here we're envisioning this is going to be a document that is linking science to global policy and sort of taking the pulse of NASA water, where we are and what we can do and how we can better respond to these water needs. So first, or next slide, please. So this is our team, and what we've done, we're trying to think outside the box. And so I'm serving as the Associate Program Manager for Water Resources. We brought in Perry Otto, who is a geoscientist and expert in decision making. And our summer intern is Artie Aurora, and she's a social scientist. So we're trying to really think outside the box a little bit and do something a little bit different. Next slide, please. And as we're seeing here, just within the last year, there are several instances of water and food security that are in the news, right? So there's many examples here, and we're looking at everything from key laws and policies to engagement criteria to even a communication strategy that will help inform and help enable NASA Earth Science products and programs to better respond to these needs. So we've seen here we have an example from Vice President Harris with the White House Action Plan on Water. In 2022, we also had the Climate Change Impacts, Adaptation, and Vulnerability from the IPCC. Many different examples of raising the bar a little bit, saying, hey, listen, we really need to respond to these needs. So next slide, please. So what we've done, first we took a big step back and said, well, what is NASA doing? How are we really addressing water needs? So we started with the U.S. Global Water Strategy, and this is a strategy from the U.S. Department of State and USAID. And really what it does, it sort of highlights areas that are critically in need of water, help for water security, and areas and ways that we can help address this. In the purple box, we see the decadal survey for Earth observations from the National Academies. And what this did is sort of highlighted Earth observations that were critical for addressing critical Earth observation needs. And in the blue, in the top box, this is the NASA Applied Sciences Strategic Plan. And each number here, these are objectives that were highlighted within the plan. So what we've done first with the International Water Strategy is seeing how we can sort of weave these together. How is the NASA Applied Sciences Strategic Plan responding to the decadal survey, as well as the U.S. Global Water Strategy and these needs that are highlighted by U.S. government policy directives? So next slide, please. I'm going to hand it off to Perry Otto. Thank you.
Yeah, thanks so much, John. And so I probably don't have to say to people who would attend this type of meeting just how important water is, right? We all kind of understand this. It lies at the nexus of food and agriculture, of climate, of energy, human development, health and sanitation. And so, trying to capture all these different elements in this burgeoning international water strategy is a real core focus of ours. And there's a lot of really excellent work being done across the agency in some of these areas already. So part of our job here is really just an awareness, improving communication so we understand exactly who is doing what with respect to water, what is the breadth of NASA's water research as an agency, how we can best leverage existing capabilities and also initiate and sustain new capabilities. And we're doing that through the lens of these different global themes here that we all try to keep in the back of our mind at all times. So we have kind of governance issues with transboundary rights, spatial scales. Are we talking globally, regionally, basin level, sub-basin, depending on where in the world we're actually looking at, as well as looking at water resources through time and in different domains. And so this is the kind of framework that we're holding in our heads in combination with the long-term guidance strategy documents that John talked about before, as we set forth into kind of actually building what the strategy is. Next slide, please. So that kind of brings us to our strategic vision. Again, just to kind of highlight big picture, ultimately the strategy will be in the form of a report where we can take a critical assessment of kind of the state of NASA's water research at the agency, understanding linkages between different research groups within the applied sciences and other research and development groups, as well as between external partners, interagency groups such as the Interagency Water Working Group in the US government, or international groups like GeoGLOS. And we're trying to kind of sum this up into a kind of a very critical overview of where we stand and possible ways that we can improve. So I won't have you read all the text that's on the screen right now, but I will highlight that mission statement, which is to facilitate international water management through applied research, capacity building, and improved coordination between NASA, its partners, and stakeholders. Next slide, please. So kind of bringing it all together, we have been discussing future strategies with a number of different groups within NASA and outside of NASA. They've all been very instrumental in kind of formulating our engagement framework that we're working with. And so again, like any good applied science program, that begins with understanding the user needs, understanding who the end users are, what problems they're trying to answer, and what capabilities that we can leverage to ensure that we're properly answering that question. So then we move into kind of partnerships, and this is getting back to the awareness part of it, understanding who's doing what existing capabilities we can use, and how we can best facilitate and create new capabilities as needed. And ultimately, the point here is to be able to facilitate new strategic, sustainable, and scalable engagements for international water research to the best of our abilities. And I will turn it over now to Artie to talk about kind of her role in the summer's program.
Thank you, Perry. I was excited to join this summer to bring my background in anthropology to help out with the strategy. We wanted to first look at and understand the global water landscape of needs, and so I looked at potentially relevant laws and policies, both domestic and internationally, to understand how NASA's current capabilities fit into those laws and policies. Next, we wanted to understand what engagements to take on that aligned with the Applied Sciences Strategic Plan's goals, given limited resources. So to do that, I distilled down the goals into a questionnaire that considers how opportunities can add value to the current US government priorities. And the last thing we wanted to look at was to try and understand how to capture current and future project impact. First, I mapped out current and past projects, their stakeholders, their partners, to try and understand where to build upon current expertise. And then I looked further into understand how to measure societal benefits with the work that is being done, and how that might require different data sets. So for example, some of the impacts we might want to measure would require very granular data about how individual people or households are accessing water. So I've spent some time trying to understand what are the data necessary to build those metrics, where to find those data, or how to collect those data. All right, I'll turn it back to John to talk more about international and interagency work.
Thanks. Next slide. So this is just a glimpse of some current international and interagency activities. Many of us are familiar with these activities already: the SERVIR, the LIS IES team, the Water Resources Program, GeoGlows. And what we're doing is we're looking at these and sort of learning from what we've done, right? And so we're reaching out, we're talking to international partners, we're talking to program managers, so we're talking to scientists, and finding out, what did we learn? Where did we fall short? And what were some successes? And what we're envisioning here is a document that will help inform future strategies, future engagements, future ways of assessing this whole engagement, and how this can help inform and increase the impact of all these things. So with that, this is our last slide. Next slide, please. And one part of this is we are building a guidance team. So all the folks we're talking to is like, hey, we'd love to learn from you. So please reach out. Sarah Brennan just provided some links in the previous thing. You can also email myself, Artie, or Perry if you have questions or feedback or suggestions. And thank you so much for your attention.
Thank you all for your presentation. Next, we'll have Dr. Kira Adams highlighting California's groundwater future.
Hi, everyone. Thank you so much. Just making sure that you guys can hear me. Let me know if you can't. Thank you so much for inviting me to highlight one of the really fun projects that we're doing with Applied Sciences. So, as you have heard from previous talks, there's a lot of work that we're trying to do here at NASA, trying to connect some of these large data sets to applicable sizes for stakeholder needs. So the work that I'm doing is California's groundwater future. And so we're trying to relate subsidence and consumption of groundwater within the Central Valley in California. Next slide, please. So just to really show the need for this kind of work, here's the Central Valley Aquifer System. It's about 20,000 square miles, and it supports a population of about 6.5 million. It's only about 11% of the state's total inland area, but it supplies up to 75% of the state's water. This is variable depending on how much surface water we have available for that year or for that season. It's of high interest because there's a lot of agriculture that is supported through the Central Valley. And so it actually generates about $20 billion in crops annually. This statistic is a little bit older, so I have seen stats go up to even $30 to $40 billion. It grows about 250 different crops. And so you could see that it supplies about 50% of the US nuts, fruits, and vegetables. Depending on the category, for example, nuts, it could actually go higher, up to 85%. Next, please. So because of that, the groundwater has been kind of the key resource that's really vitalizing the state and also the nation. And you can see here in the graph, this is a modeled result from USGS, that groundwater has been depleting very drastically. So you'll see here in the navy line, that's the model overall groundwater for Central Valley. And you can see, from the 60s to maybe the 2003 year range, it's been really drastically declining. This groundwater is equivalent to about a third of Lake Erie. And because of this, groundwater depletion is causing a lot of geological structural problems within the state. And so if you see in that smaller figure down below, you'll see that there's some kind of compaction going on. So what's going on in the deeper layers is because these grains are supported by the pore water, as we pump groundwater and use these groundwater resources, the grains rearrange. And some of these finer clays actually tend to lay flat. So what you're doing is really compacting those fine grain layers. This, if you go to the next picture, please. Yeah, so this manifests on the surface as subsidence, and you can see that, you know, within from 1925 to 1977, so within about 50 years, that's how much subsidence has occurred. This is a problem in two different fronts. First of all, you're damaging a lot of the civil infrastructure, you know, breaking canals and roads and bridges. And then on the other front, you're actually permanently losing that amount of groundwater storage available at the subsurface. Next slide, please. Within that, there's the Sustainable Groundwater Management Framework that actually came in during Governor Jerry Brown's term in 2014, and it's shortened to SIGMA oftentimes. So what you see in this figure here is the Central Valley, and it's been divided into these groundwater sustainability agencies, or GSAs. You'll see that some of the southern portions of the Central Valley, which actually has a lot of water shortage issues, is very red. And so it's a GSA priority level of very high. So these very high GSA priority classification actually mandates that they need to have these management plans for sustainable groundwater depletion. And so we're right around that term where all of these plans are being submitted and trying to, and these GSAs are trying to figure out what's the best plan for some of these water management crises. The problem with this is that in situ data tends to be inconsistent. And so our question for this work was, well, can we use NASA remote sensing data sets to kind of assess this depletion and subsidence relationship in these GSAs? Next, please. So this was a study that was published in 2020 in JARA. And so what we did was we actually took a hard look at some of the available in-situ data within the Central Valley. And this was just to really motivate the use of remote sensing data sets. And so you'll see here, this is in-situ wells, and you'll see that there are a lot of station locations, which is really encouraging. But then if you look at the middle plot of station density, you see that the density of stations are actually fairly non-uniform. There's one sub-basin down in the Delta Mondota region where it has a lot of wells. But the really sad finding was if you look at the number of observations, it's very limited, especially in the southern portions where subsidence has been a major issue. Next slide, please. So based off of this work, we started to integrate some of these remote sensing data sets. For groundwater, we used GRACE and GRACE FO data, which uses gravity to measure the mass of groundwater. One of the novel things was that a lot of our stakeholders were very uncertain about using these large data sets because of the spatial scale. But we actually use a data assimilated GRACE and GRACE FO, which scales it down to 1/8 degree and makes it a little bit more relevant for management scale. And then for subsidence, we use Sentinel-1, which is an INSAR technique. We did use a little bit of the ALOS-2, which basically uses radar to understand, well, how much vertical change was there on the land surface. And I will mention that the relationship between groundwater depletion and subsidence tends to be a little bit tricky because the relationship can vary spatially and also temporally. But for this study, we just started to synthesize them within these GSAs and groundwater subbasins to understand how they relate on a timescale. So we did some timescale analyses. Next slide, please. And so we did find really encouraging results. This was, again, can you go back to the next? Yeah, thank you. So this was, again, part of that work that was published in 2020. So in the blue line there, you're seeing the signal from GRACE, GRACE data assimilated. The dotted gray line is the wells, and this was for the Delta Mendota subbasin, which really had a lot of those denser wells. And you can see that the GRACE and the well signals correlate fairly well. It's capturing the highs and the lows of the seasonal peaks, and also that yellow highlighted area where we have that large drought. So this was very encouraging. But if you go to the next figure, where we're trying to use INSAR, which is the red signal there, and trying to correlate with the GPS measurements, which is the green line. Because of the shorter record that we had for INSAR, it was a little bit hard to draw some conclusions from this work. But if you see the citation down there below in Vasco et al. 2022, we actually were part of also a team that was working to create some of the more complex models that use inversion to relay some of the groundwater depletion and land subsidence. So this work is still ongoing, and we've made some good progress. Next, please. So now I wanted to really show you some of the tools that we're developing here at JPL. So this tool, we've named it Virgo, or the Visualization of In Situ and Remotely Sensed Groundwater Observations. So if you play the video really quick. So here's Central Valley. You can hover over some of these subbasins, and the user could go ahead and click on a subbasin for more info. It will then show you some information about the coverage, how many wells there are, how many GPS records. It will automatically populate a time series. You can start to toggle different tools and zoom in to see where these individual points are. And then you can see a fairly raw time series that hasn't quite been processed. So this is the first version of Virgo that we developed with the Develop 2020 team. And so you can see some basic stats here. You'll be then able to go to a different one, showcase this one. For the records, you are able to kind of turn on and off which one you would like to see. And then you can also adjust the time frame here on the bottom. We don't allow the users in this version to download the raw data themselves, but they can download the figure if they would like. So we'll spend a little bit more time watching this video so you can download the figure. In the interest of time, I'm going to move on to the next slide, please. So now we are working on the second installment of Virgo. So we are starting to develop a little bit more of a cleaner user interface. We are iterating within the JPL team with some data scientists and software engineers here to make it best usable for some of these GSAs to get a really quick understanding of what's happening to their groundwater and also what's happening with the land subsidence. So these are some of the screenshots from our team. It's still under development, but you can see that the colors are a little bit more clear. We've gotten rid of some of these toggles just to clarify everything for the user. If you go to the next one, please. You can turn on and off these subbasins again. Instead of just showing priority or anything like that, we actually show the average well water depth in the standard deviation below historical mean for that month that we're looking at. And so it's a little bit easier to get, where are we right now in, let's say, August of 2022? What's our status for this specific subbasin? And then next, please, if you click on one of the subbasins, it will automatically pull up this pop-up window, and it'll show you, this is still being cleaned up, but it'll show you, how many wells are below historical mean, so how many wells are kind of in trouble. For this month, we have this groundwater health metric where we're trying to experiment with showing grace in different forms. And so this is under development. Next, please. Lastly, I wanted to show you some of the other efforts we're also doing as part of this project. So this was more of an artistic effort, trying to communicate to the public that there are, these NASA data sets and they could be used for environmental parameters. So this was done with Data to Discovery with Caltech. And what you're seeing here is each of these graphs are data that is pulled from a NASA data set. So we have precipitation on top, we have snow, we have also reservoir surface water, which is actually from Department of Water Resources, and then groundwater on the bottom. And what you're seeing is as the user starts to toggle through, it could see different months and how they change relative to each other, which is that little bubble plot that you're seeing that looks like a blooming flower. So you're seeing for certain months, the reservoir has a bigger slice of the pie and things of this nature. And it was really great because this won the AGU visualization competition. And so we're also experimenting with some of the artistic efforts to convey NASA data. So with that, I will end here and thank you very much.
Thank you, Kira. So next we're going to have Erin Weitzel present on the Yampa Water Resources Project.
Thank you, Sarah. So my name is Erin, as Sarah just said, and I am from the Colorado Yampa Water team. We consist of Sonoran, Sauda, Ethan Gates, and Morgan Gutman, and myself, and we'll be looking at water quality and algae blooms in the upper Yampa River watershed. Next slide, please. So to give you a little bit of background about our project, we are interested in the upper Yampa River watershed because it plays a key role in providing water to the Colorado River. In addition, it is important in providing drinking water and recreational opportunities to residents and tourists in the area alike. And the watershed consists of many water bodies, 9 of which we are investigating in our project. And a lot of these water bodies have been having issues with harmful algal blooms, which negatively impacts the water quality and also reduce tourism, which impacts local economies. These lakes are also important because they are low productivity, and so they are therefore sensitive to changes in result to runoff events or snowmelt events. Here we have our objectives. So we wanted to analyze the trends in water quality over time, as well as fill historical data gaps that our partners identified having and expressed some concerns about. Additionally, we wanted to assess the viability of remote sensing as a tool to analyze harmful algal blooms and water quality in this area. Next slide, please. So here we have a change map. This is looking in particular at Lake Catamount, which is one of our 9 lakes of interest. On the top there are the various water quality parameters that we use to assess the trends. So true color is just your satellite imagery. AVW is a measure of water color. Temperature is your water surface temperature. BWAI is an algae index to visualize those algae blooms. And then greenness is how green the water is. So in that first row there, in the true color imagery, you see a lot of green. That is a harmful algae bloom. And then over on the right in that 4th column under BWAI, you can see that bloom in the yellow. And this is really exciting and interesting for our partners because they can look at this and then make connections between the other water quality parameters, such as the temperature on the left-hand side of that BWAI image. You can see that more pink area. That's an area of higher water temperature. And this is exciting to see because we know that that algae likes to grow in those higher water temperatures. Here is a time series plot. We made several time series plots, all of them for those water quality parameters that we just discussed in that map. So this one in particular is looking at surface temperature for 3 different lakes of interest. On the right there, you can see the first is for Lake Catamount, the second is for Stagecoach Reservoir, and the third is for Steamboat Lake. And this plot is really interesting because you can see for all 3 lakes over time from 1984 to 2021, which was our study period, that you can see an increase in temperature. And so this is interesting for our partners because we know that algae likes to grow in those warmer temperature waters. And this would suggest that they might need to mitigate more algae blooms in the future. Next slide, please. So here are our conclusions. We just wanted to reiterate our main objectives and how we were able to accomplish them. So firstly, in regards to filling historical data gaps, we were able to do so constructing those time series plots and those change maps to provide our partners with more information of how the watershed changed over time. Additionally, we were able to assess the viability of remote sensing as a tool for monitoring water quality and algae blooms by creating validation plots, which compared the remotely sensed data from in situ data that we obtained from our partners. And from these plots, we determined that there was a limited amount of in situ data, and therefore we were not able to say fully that it is a viable tool. However, we suspect that with more in situ data, you would see a strong correlation that would support that remote sensing can be a viable tool, since we did see those trends in that remotely sensed change map. Lastly, we were able to analyze trends in water quality over time by assessing those maps, as well as looking at our time series plots. And especially in those time series plots, we were able to see mixed trends or varied trends over time, especially in regards to our water color measurement, AVW, the algae index, BWAI, and the green band. And so with that, that concludes our presentation, and I thank you so much for your time.
Thank you, Erin. So next we have Sophia Fall, who will be presenting the Puget Sound Water Resources Project.
Hi, I'm Sophia. I am on the Puget Sound Water Resources team from the Colorado node, along with Mike Kitchener, Lily Oliver, and Lindsay Zemenek. Our project used Earth observations to map bulk kelp in the Puget Sound, Washington to support conservation and restoration. Next slide, please. Bull kelp is a common marine macroalgae species found throughout the Pacific coast and the Puget Sound. It provides critical habitat and ecosystem services for nearshore marine species and communities and plays a foundational role in food webs in the region. It can grow at depths of up to 20 meters and forms canopies visible from the surface and in remotely sensed imagery. Its peak growing season is mid-July through mid-September, and in winter it dies back from the surface. Bull kelp is extremely sensitive to environmental changes such as warming temperatures, nutrient concentrations, trophic cascades, and wave action. And because of this, it's very vulnerable to environmental and anthropogenic impacts. Bull kelp has been declining globally and in the Puget Sound. And in addition to the loss of its ecosystem services with these declines, bull kelp has cultural and historical significance to communities around Puget Sound, which are also lost with these declines. However, these changes in kelp extent and distribution are not well tracked or understood due to the expensive and time-intensive nature of kelp canopy monitoring, which mostly has to be done by manual surveys in the Puget Sound. We partnered with the Port of Seattle and Washington State Department of Natural Resources to investigate better monitoring efforts through remote sensing. Next slide, please. So in order to help our partners in developing tools and methods for more efficient kelp monitoring, we initially set out to evaluate and compare the feasibility of using satellites for bull kelp monitoring. If those satellites prove to be effective, then we aim to produce kelp extent maps for 2021 and a time series to show how kelp had changed over time and extent for a 10-year period from 2011 to 2021. However, we found that the dynamic nature of nearshore marine environments and the characteristics of bull kelp itself proved very challenging for the sensors that we were investigating. Bull kelp, as you can see from this drone photo taken by my teammate Mike, grows not in continuous swaths like forests or other terrestrial vegetation, but in patchy beds that are interspersed with water. So when we attempted to isolate the spectral signal for kelp from water, we found that our data sets contained a lot of noise from environmental factors like wave action, turbidity, and particularly tides and currents. So for this reason, we found that mapping was not yet appropriate. Next slide, please. So tides and currents particularly impact the visibility of kelp canopy in remotely sensed images, which means there's only a small window of the hour before and the hour after a low tide of 1 foot or less for optimal image acquisition for full canopy observation. Because of the rigid timing of the Landsat 8 and Sentinel-2 satellites that we used for our project, we found this to be an important limitation on bull kelp mapping. Other types of remote sensing, like aerial drone surveys, could help overcome these limitations. So we found that there is room for further development of remote sensing as a kelp canopy monitoring tool that can more efficiently and effectively track changes in kelp canopy over time, particularly if used in combination with traditional survey techniques for validation. And that's an overview of our project. Thank you so much.
Thank you, Sophia. And so next we have Natasha Sadoff, who will highlight the PACE mission.
Thank you. I hope you can hear me. Hi, everybody. Thank you so much to the Applied Sciences team for giving us the opportunity to participate in this week. We're very excited. My name is Natasha Sadoff. I'm the PACE Applications Deputy Coordinator, and I'm basically going to tell you about a new mission, pre-launch, that is going to provide an opportunity for some new data that can enhance the types of applications that we've heard about today. Next slide. So the PACE mission, or Plankton Aerosol Cloud Ocean Ecosystem Mission, is NASA's next great investment in global ocean color and aerosols. PACE is going to extend ocean biology, ecology, and geochemical data records. It's going to extend cloud and aerosol data records, and it's also going to make new global measurements of ocean color essential for understanding things like the global ocean carbon cycle, ocean ecosystem, and other things that are impacting our changing climate. So PACE is also going to collect global observations of aerosols, cloud properties, and help us reduce some of the largest uncertainties in climate and radiative forcing models. When it launches in January 2024, the PACE Observatory is going to have 3 instruments. The first is a hyperspectral scanning radiometer referred to as the Ocean Color Instrument, or OCI. OCI is going to provide continuous spectral resolution from the ultraviolet through the visible into the near infrared of the spectrum. And then there's also 7 shortwave infrared channels that are useful for atmospheric science, as well as for coastal oceanographic science. There's also 2 contributed multi-angle polarimeters on board, HARP-2 and SPEX-1. They're contributed to the mission to help collect global aerosol and cloud properties, but those aerosol and cloud properties, atmospheric characterization is going to help make the ocean color data even more reliable and detailed than it's ever been before. Next slide. So this is a video. If you can click, there should be a play button if you hover over. Yeah, there we go. So just to underscore the importance of what PACE is going to allow us to see, this is an image from a simulation of the MIT general circulation model. So this is a model that contains inorganic nutrients, 78 species of phytoplankton, zooplankton, and particulate and dissolved organic matter. So the colors are representing some of the most dominant forms of phytoplankton based on their size and ability to uptake nutrients. So this is model data, but PACE is going to provide observations and actual spectral data on these types of distinctions. So most notably, we'll be able to see phytoplankton type. And again, that's globally every 1 to 2 days. So obviously this is very powerful. Next slide. So given the power of the image on the previous slide, and given the system of systems, kind of Earth systems approach that PACE has, there are obviously wide-ranging applications here for water resources, also for climate, air quality, atmospheric applications. So it's obvious that PACE is going to contribute to all of the applied science objectives, and a few of them are noted here related to water quality and water resources. So everything from fisheries to harmful algal blooms, and obviously across a lot of different human health areas. Next slide. So the PACE mission, and you can click through these slowly. Yeah, there's 6 of them. Thank you. The PACE mission has an applications program, and that's where I sit and my colleague Erin Urquhart. And our job is to make sure that PACE data will be actionable, useful, and accessible. So we have a lot of activities that are meant to foster relationships, create a PACE community, enable future uses of PACE data. So our early adopters program is one way that we do this. So Erin is actually going to talk about the early adopters program tomorrow, so I hope you'll stay for that. But these are just some tiles from a few of our early adopters and what they're doing pre-launch so that when PACE launches in 2024, they'll be ready to use that data. So there's applications supporting how phytoplankton impact marine mammal ecology, fisheries, sustainable aquaculture site selection, harmful algal blooms in California along other coastlines, in large inland lakes, and then water quality, water clarity, reflectance as an indicator of water quality and habitat health. Next slide, please. So we're very excited. We hope that hearing a few minutes worth of PACE information will get you excited as well. There's lots of ways that you can learn more and get involved, particularly as we gear up for launch. So we are having our annual workshop that's in September. Come and learn more about PACE science and applications. We also welcome you to check out our early adopters program and apply if you think you have a novel application area where you think PACE could contribute. We also have a community of practice if you'd like to stay in touch and receive our newsletter. And then finally, stay tuned for some future solicitations that will come out of the PACE program. So next slide is the final slide. Just thank you for your attention. I hope that you're excited about PACE. If you want to learn more, please contact us. And we look forward to seeing you at an event in the future. Thank you.
Thank you so much, Natasha. And I will now pass it over to Lawrence Friedl to wrap up to day 2 of Earth Science Application Week.
Great, thank you so much. So we've come to the end of day 2 of our showcase, and many thanks to the Sarahs for their expert emceeing. Today, we gave some special attention to partnerships. Obviously, we started off with USGS and Landsat and the 50th anniversary of that. We talked a lot about Develop and the National Park Service and the fantastic partnership there and some opportunities that are coming up. USAID and SERVIR, multiple federal and state agencies and other communities with the Wildland Fire program and with the water program, you name it. There's partnerships after there. And so it was another Sarah Brennan, that I think gave a great framing of this sort of engage, access, and drive. And I really think that sort of is representative work across applied sciences. So that was fantastic. So in the ending today, we hope you'll do your own reflections on the day. What are some key items that you sort of took away from this day 2? Maybe it's ideas for people that you might want to make connections with. Maybe there's ideas for new applications or something. Maybe that's also confirmation of some good practices that you're doing and that you want to continue. Actually, hopefully it's both of those. So as wrapping up day 2, we want to be turning our attention to day 3, and that'll be the final day. We're going to have a lot of focus on agriculture and disasters. We're also going to be focusing on a partnership that we have with Bhutan. And then there's also going to be looking at ways for you all to get involved across the program. So we're going to be looking at some things related to prizes and competitions. You heard about early adopters. You're going to hear more about that tomorrow. We're also going to be hearing about open science and open source science, which is a big push within NASA Earth Science and the broader NASA science activities. Last year around this time, we released our new Applied Sciences Strategic Plan. A little bit earlier this year, we did a big release of our Earth Science Applications Guidebook. And so we're really excited about that. And actually tomorrow we're going to have a special session specifically on that guidebook. So hopefully you'll turn into that. And then finally tomorrow we're going to have a bunch of people from NASA leadership to help close out this week. So we'll see you on Thursday. We start sharply at 1 o'clock Eastern Daylight Time. So have a great evening and we'll see you back tomorrow. Back to you, Sarah, for closing it out.
I think that pretty much wraps it up.